안녕하십니까.
Good morning, everyone. We will begin the International AAM Technical Meeting sponsored by MOLIT and hosted by KIAST. So this is our day 2. I am Dr. Yoonbum Soo from UAM Technical Center of KIAST, and I'm also co-host Yoon Hee-jung. Nice to meet you all. Today's event is also an international event, so simultaneous interpretation will be provided. Please select channel 1 for Korean, channel 2 for English. This event will be live streamed on the YouTube channel and also Event Us. Visit our Team Korea channel for English and KIAST channel for Korean. I haven't received the information about how many people access today's event yet, but I heard that around like 340 to 350 people joined us on Eventus, and we also have around 100 additional people at the venue. For those who joined us online, you can leave your questions in the comments, and we'll relay these questions to the speakers later in the panel discussion. Before we begin, let me summarize yesterday's discussion. So we discussed the policies of important authorities and how R&D projects are conducted here in Korea and also overseas. So you were here with us for the day 1 event. So I first thought UAM is a distant future, but now it is already becoming a reality. That's why I am more excited for the day 2. So I believe we'll be able to share insights and useful information with you today. To give you a brief introduction, our session 3 and session 4 will be about certification and industry standards trends, and also UAM industry trends respectively. As for today's morning session, we will have experts in ASTM as well, so we look forward to your active participation and interest. We actually have Philip Cannell, Chair of ASTM Technical Committee F38 for congratulatory speech.
Committee F38 will speak the congratulatory speech. 그래서 한번 만나보도록 하겠습니다. 여러분 큰 박수 부탁드리겠습니다. Good evening, Mr. Philip Cannell. Please.
Well, good morning to you in Korea.
Yes, thank you. Please go ahead.
Yes, good morning to you in Korea and good evening from Washington, D.C. On behalf of ASTM International, it's an honor to join the Advanced Air Mobility International Program, sponsored by South Korea's Ministry of Land, Infrastructure, and Transportation. And having engaged with KIAST now for over a year and joined them in regular discussions, it's a pleasure to see our collaboration come together in today's panel session on certification and policy trends. In my work with standardization and in chairing the ASTM Technical Committee F38 on unmanned aircraft systems, it is impressive to see the collection of international experts, the body of knowledge, and the commitment at time that comes together to formulate industry consensus standards that address all types of challenges. And those challenges are both technical, regulatory, and they have global applications. In ASTM, the impactful outcome on UAS and related topics is the result of work across at least 3 technical committees comprising over 800 individuals from more than 35 nations. As the standards are taken up by industry and regulators, they are becoming the best practices and technology tools that are building and expanding a new industry worldwide. And we have a focus, in addition, on safety, reliability, and acceptance. We are grateful to KIAST for the invitation to contribute information to today's program. The ASTM session features the learned experience of our 4 expert speakers who you'll hear from soon. And I want to express my appreciation to Amit Ganju, Tom Gunnarsson, Jonathan Daniels, and Rex Alexander for preparing their materials and joining us today. You'll hear about relevant standards from ASTM and other developers that support certification and policy. And in addition, you'll learn about the work being done to understand what standards are still needed and how efforts are being coordinated internationally. I'll close by encouraging you to ask questions during the question and answer session. You are welcome to participate in ASTM standardization activities. And let me again express my appreciation to MOLIT and KIAST for inviting ASTM to this forum to share the information and connect with a wide range of stakeholders. Thank you again, and now let me turn the program back to you.
네, 개회사를 해주신 필립 커널님께 다시 한번 큰 박수를 부탁드립니다.
Please give a warm welcome and a big round of applause to Mr. Philip Connell. So the ASTM has been closely collaborating with us for more than a year. So taking this opportunity, I believe we will have further strengthened cooperation with ASTM. So without further ado, I'd like to start session 3 of today's event. So the first session of day 2 will be focused on certification and industry standards.
무인 항공기 인증 체계 및 인증 기준 개발이라는 주제로 발표해 주시겠습니다. 큰 박수로 환영해 주시기 바라겠습니다.
예, 여러분 안녕하십니까? 그리고 유튜브를 통해서 본 채널을 시청하고 계신 모든 분 안녕하십니까? 반갑습니다. 저는 방금 소개해드린 바와 같이 항공안전기술원에서 UAM, UAS에 대한 인증 체계와 기술 기준을 연구하고 있는 남궁평 책임연구원입니다. 예. 제가 오늘 준비한 발표 내용은 우리나라의 무인 항공 체계에 대한 인증 지침 그리고 전략 이에 대한 연구와 그리고 인증을 하기 위한 가장 중요한 요소인 인증 기준 개발 이러한 등을 에 대해서 간략하게 말씀을 드리도록 하겠습니다. 예, 말씀드릴 순서는 먼저 UAS 인증 시스템 그리고
I will start with UAS certification system, and then UAS airworthiness certification standard, how we are going to validate it and prove it through means of compliance, and fourth, future actions and conclusion. First, UAS certification system. I think we already have discussed this in session 2. It was briefly mentioned by Dr. Yu Chang-son. So
UAS를 최종 목표인 미래 도심 항공교통
we in Korea are aiming at the unmanned UAM.
완전 무인화에 대한
So
기술 기준을 개발하고
we are now developing technologies and certification strategies and guidelines. Starting in 2019, as you are seeing in the pictures, we started this project with KC-100. So this used to be a manned aircraft, but now we are converting into an unmanned aircraft. This project will continue for about 5 years.
개조는 전체적으로는 사업 컨트롤은 항공우주연구원이 담당을 하고
So
기체 개조는
modification will be done
사업 카이가 되겠죠.
by KAI or Korea Aerospace Industries,
GCS 즉 지상 컨트롤
and ground control system will be
하고 있고 저희
done by Cetratech.
기술원에서는 이런
At KIAST,
모든 기술적 능력을 검증하고
we are trying to validate
인증 기술 기준 개발과
these technologies by developing certification standards
하는 그런
and
임무를 수행하고 있습니다.
guidelines.
좀 더 구체적으로
So to give you more details,
가장 중요한
so the purpose of this project is to develop
그리고
UA certification
이
system
기술 기준을 개발하는 것을
and
어떻게 검증할 것이 하는
guidelines,
방법
and we also try to design compliance verification methods.
하고 있고 사업 기간은 말씀드린 바와 같이 약
The
5년까지
research will be done for 5 years,
진행될 예정입니다.
so it will be completed by December 31st, 2023.
우리가 획득할 수 있는 것은 가장 중요한 것이
So I believe through this research,
과정을 통해서 획득한 중요한 요소인 기술, 핵심 기술을
we'll be able to achieve
이를 바탕으로 한
certification standards for core technologies
우리나라만의 고유한 카스, 즉 한국에서
And
적용할 수 있는 무인 항공기에 적용할 수 있는 항공기 기술
KIAST
기준을
technology standards,
최종 목표는
which will be unique to Korea.
모든
The government will announce these standards and guidelines to the industry,
체계를
so we'll be able to run
자, 이러한 그
manned and unmanned aviation
네 단계로
by
2023
KARI.
운영되게 되겠고요.
So this will continue until 2023, and as for this year,
유인 항공기를 무인화하는 개조 작업은 완료가
I think we have completed most of the conversion,
시험 비행을 하고
turning the
나타낸 여기서
manned
획득할 수 있는
vehicle
기술
into unmanned vehicle.
수립을 해야 되겠죠.
So now we need to identify and establish what kind of technology can achieve for standardization.
상시험
We are going to conduct all these simulations, ground tests, so we can
초도 비행을 해서
start the first flight at the end of this year.
이렇게 해서 이제 본론에 들어가기 앞서서 우리나라가
Before dive into the research,
인증 체계 수립과 그리고 기술 기준을 작성하고
UAS certification system
과제화해서 추진하고
and
있다.
guideline development,
우리 보시는 분들과 우리 참석하신 분들께 먼저 말씀을 드리고
that's what I'd like to tell you that this is what we've been pursuing.
자, 무인 항공 시스템을 인증한다.
So certifying UAS,
쉽게 들릴 수 있을지는
it sounds very simple,
매우 어렵습니다.
but actually this is very difficult
정책적,
because it involves
제도적,
policy, institutional support,
그러한 기술적 뒷받침이
and we also need technical
가장
support.
중요한 요소를 제가 두 페이지를 걸쳐서 한번
So
요약.
let me give you the key points, 2 key points. First,
규정이 따라줘야 되겠다.
acts and regulations.
그다음에 법 규정에 따라서 이를 실행하는
And based on it, we need an organization that will implement the
가 될 것 같고.
project or the business. So
정부에서 업무를
here in Korea,
위임하는
this will be
의기관,
MOLIT.
즉 항공안전기술원에서
And KIAST
이미 다 갖추고 진행을 하고 있습니다.
is also one of these organizations involved.
법령의 틀 안에서
With these acts and regulations and organizations, how we are going to run UAS certification systems. Then, of course, here we need to think about the procedure for certification.
그다음에 더욱 중요한 거는 기술적
And what's more important is
어떤 기준을 가지고 인증해 줄 것인가 하는
what kind of technologies will be used for certification. So that means we need standards.
법과 절차는
Acts and regulations are policy matters. So I think as early as within a year, I think we'll be able to introduce the necessary acts and regulations. But we have people from the aviation industry, and we also have many experts in the industry
기술 기준을 만든다.
developing technologies and standards
기술 기준을 만든 것은
for certification.
짧게는 뭐 10년
Well, it may take as short as like 5 years or 10 years. I don't think it is something that can be easily achieved. It requires a lot of effort, simulation, to validate the idea and technologies.
자, 이 페이지 상당히 중요합니다.
So this is a very important slide.
현재의 우리나라의 항공안전법 2017년에
According to the Aviation Safety Act, I have categorized
등등으로 분류했는데
different vehicles or aircrafts.
자, 지금
So as you can see here, the yellow boxes, the yellow cells
C로 분류를 합니다.
are for ultra-light vehicles,
파란 박스에
and the blue one
항공기급으로
is
분류되는
for
안이 되겠습니다.
aircraft.
여기 계신 분들도 그렇고 우리 많은 분들이 이제 드론에 대해 관심이 많으신데
Many of us, including those who are here, are very interested in drones, but
드론 이게 뭐지?
most of them are not aware that drones are the vehicles that are remotely controlled.
가까이 되면 네.
Okay, I will speak closer to the microphone.
죄송합니다.
I'm very sorry.
커뮤니케이션 안 돼가지고. 그래서
Okay.
제가 지금 우리나라 항공안전법에 명시되는 자료를 좀 정리를
So
해보았습니다.
this is the categorization based on the Aviation Safety Act, how we are going to categorize unmanned aerial vehicles
페이지
according to the law.
봐도
So if you
정확하게 소중한 정보를 얻어가실
take
수
a look
있습니다.
at this slide, just this slide only, you'll be able to get very valuable information.
법률이 제정이 됐죠.
So a new law was enacted last year to activate the drone and the related industry, but the drone was defined
항행할 수 있는 비행체
as a vehicle
그런데
which does not require a pilot but can fly on its own. Then does it mean that all vehicles that does not
드론에 대한
involve a pilot is a drone? Well, I don't think so.
분량에 대해서는
It doesn't really, this definition does not include the weight information.
사망에 따르면
According to Article 3-2 of the Aviation Safety Act,
드론에 해당됩니다.
when the aircraft's weight is below 150 kilograms, that's drone.
구역 내에서는 자유롭게 비행할 수가 있습니다.
In this case, you can fly your drone freely within a limited space, but the weight should be below 150 kilograms. But what about the unmanned aircraft whose weight is above 150 kilometers? It is categorized as an aircraft according to our act. That means that safety certification alone is not enough.
하기 위한 기술
Airworthiness certification is required here.
말씀드린 바와 같이 정부에서는
So,
과제 사업화해서
for this, the government has issued a project, announced a project for this,
만들겠다.
to develop the necessary technology standards.
이것만 아셔도
So this is all you need to know, then you will
드론이라고 하는 게 아니다.
pose as an expert
구분할 수 있다.
in the industry,
인지할
because
수
you
있다.
know that the weight is what decides
그래서 절차는 간략하게 설명을 드리면
the difference between a drone and an aircraft.
그래서 뭐 신청자와 신청을 하면은
So when you apply
사망 인증
for type certification, the government will start the airworthiness certification, then the
에 대한 디자인,
applicant
실험 이런 등등을 통해서
need to
최종적으로
experiment have an experiment with its UAS design,
즉
and
검사관들에 의해서
you also need to do some ground and flight test, and after an audit and inspection,
부족했는지 여부를
when all the specs and requirements are met,
형식 증명서를
a type certification will be issued.
중요한 게 빠져 있죠.
But
뭘까요?
something is missing here.
어떤 걸 가지고 검증할 것이냐.
what will be used for certification, how we are going to assess compliance. So here we need standards. So let me go back to the standards and explain them.
지금 현재
So
제조 개발한
on your right is the picture you're familiar with. This is our modification process for KC100.
개조가 필요 없는 부분
There are some parts that does not require modification. Of course, we are going to use them as they are,
디자인 체인지가
but there are some parts requiring design changes,
K10에 적용했던 기술 기준의 수정본을 반영을 하고
and modified designs will be used here.
무인 항공기 체계에 신기로 적용되는 핵심 기술, 즉 그라운드 컨트롤 시스템,
And ground control system,
시스템,
remote control system,
그리고 통신
C2,
그다음에
data link,
컨트롤에 대한
flight control,
컨트롤 메인 컴퓨터, FLCC
computing.
그야말로 말씀할 수 있는 뉴코어 핵심 기술
These are new standards
기준을
required.
이런 내용이 되겠습니다.
That means that we need to add new standards here.
우리나라의 경우는 제가 말씀드린 바와 같이 이런 과정을 가지고 추진하고 있는데
So this is our process in Korea, but let's look outside Korea for a moment.
미국은
First, the US.
미국은 기존의 유인 항공기 고정익 회전이
Fixed wing
설계 개발에 필요한 유인
airplane
항공기 기준을 가지고
technically standards
적용을 한다. 다만
are used for UAS to still. There are specific conditions. Special conditions will be added for UAS for additional certification.
반면에
And meanwhile, in the Europe,
EASA 중심, 즉
EASA
안전청, 민간 항공 안전청
takes center
중심으로
stage
인증을 기준과
in establishing certification and standards. So there's difference between the two regions.
항공 시스템을 먼저 운영자 측면에서 어떻게 운영할 것인지 이 중요한
So how it will be operated from the perspective of an operator, where it will be operated. That means that in US they assess risks first,
민가가 밀집하지 않은 지역에서 운영하는
whether it is
중량 25kg
operated
해당하는 그런 아주
in a densely populated area or
되면
whether it weighs below 200 kilograms. That means that
지역에서
if you meet the requirements, you will get the certification. But if there is any risk of flying in a densely populated area, or if there is any risk of collision, and
타당하다. 리스크가
risk analysis will be conducted, and when the risk
그렇지 않고
is not found, the certification or the approval for flight will be issued.
별도의 인증 과정을
But if there is any risk identified, then you have to go through the certification process. Then how it will be done?
이건 스탠다드에서 다시
Well, let me go back to it when I talk about the standards.
어떤 기준을 가지고
So which standards are used for flight approval and type certification?
다음 장에서 다시 설명.
Let me cover it
그리고 이어서 이제
in the next chapter.
스탠다드에 대해서
So
말씀드리겠습니다.
let me go back to the standards once again.
우리나라의 경우 스탠다드
In Korea,
먼저 민간용 항공기를 살펴보겠습니다.
first,
민간용
civil
항공기
standard, civil aircrafts.
상세하게
So there has been very detailed standards for manned civil flights.
뭐 미국에 있는 항공기 설계 기술 기준을 바탕으로 해서
Based on the flight design standards of the US, we have established a very good organized standards in Korea. And for military aircrafts,
적용해서
we are using the European standards as a basis.
여기서
But
마찬가지로
here once again,
민간 항공기 같은 경우는
as for Korean civil aircrafts,
체계에 대한 기술
we
기준을
don't have
마련되어
any
있지 않다는
UAS
것이 중요한
standards. That's the key point here.
미국입니다. 미국의 경우는 방금 전에
In the
소개드린 바와 같이
US,
유인기에 대해서 정확하게
they have very accurate, detailed
있고요.
civil aviation standards,
아직까지 UAS에 대해서는
but they don't have clear certification standards for UAS yet.
유인기에 대해서 추가적인
But
스페셜 컨디션을
if you add special condition to the existing manned aviation standards, you can get the certification on approval. But as for DoD, Defense, Department of Defense of the U.S.,
그러한 기술 기준을 제정해서 운영하고
they have a different standard for military approval and certification.
유럽 항공 안전청 이하에서는 아직까지 CS
Then as for the U.S.,
가지고 있지 않습니다. 다만
but they don't really have any standard for
민간 항공
here in Europe yet. But there is JARUS.
여기 기구에서는
There is JARUS in Europe to cover the civil aspect.
LUAS, LURS 이런
CSUAS, CSL, UAS
차원에서 수립해서 운영하고 있습니다.
are
뭐 말씀드린 바와 같이 네이토는 방금 설명드린 데와 동일하고요.
are established by a civil organization. And there is also standards from NATO.
한 8년 정도 이전부터
So I think it was first established back in 2008 and it has been continuously used.
우리나라에만 적용할 수 있는 특화된 UAS
So Korea-specific UAS standards will look like this.
활용되고 있는 유럽과
We are going to leverage the standards of the US and Europe,
환경에 부합되는
both manned and unmanned, and identify the special conditions for UAS.
앞서 정부 과제화해서 추진하고 있는 과제의
So that's
시가 되겠습니다.
the key point of our report conducted as part of the government project.
현재까지 2021년까지 작년 말까지 우리
Until last year,
기술원에서 나타낸 성과는
at KIAST, we have
스페셜
obtained some achievements. So we have identified some special conditions for UAS.
우리 국민 여러분들께서 타고 다니실 안전한
Safe
UAM을 위해서
UAS that will travel
핵심 기술을
over urban sky. We have identified Air 8 core technologies, and we've been developing standards for them. And until last year, we have completed the standards, the establishment of the standards for the 2 technologies. And now we are working on the remaining 6.
만들 계획.
And the technology guidelines will be also mapped out this year.
그래서 이것을 우리 항공 안전 기술원에서 그냥 그 브레인들이 모여서 하는 것.
So we have talent at KIAST to put their brains together, heads together. But we also need to work with the industry and academia.
그분들의 그 의견과
Their opinions and ideas should not be missed.
저희가 이런 그 핵심 기술에 대해서는
To avoid that,
국내 최고 전문가들을
we
모셔다가
have invited
스포트 테크니컬 커미티
top experts
전문가 기술
to organize the expert committee
4개의 보시는 바와 같이
for
4개의
UAS. We
전문가
have
기술위원회를
4
구성해서
technical
운영하고 있는데
committees
향후에는
with the experts.
2023년 말까지 이 기준이
By
완료될
the
때까지
end of this next year,
약 6개 정도의 전문가
I think we will run
구정을 해서
additional 6 technical committees to find the best solution for certification guidelines and technology standards.
예, 그리고 다음에는 이제 means of compliance.
And now let's talk about means of compliance. So when we have the
절차가 마련되고
guidance, procedures, and technologies
기술 기준이 있고 이게 두 가지
and
요소가
standards for
성립이 되고
proving
나면
or validating the technologies,
마지막 파이널적 요소인
lastly, we need means of compliance to validate them. So we call them,
어떤 방법으로
in short, MOC or means of compliance.
보시는 바와 같이 연구 검증 확인하는 방법은 분석,
So we have to analyze, review documents,
시뮬레이션이죠. 그리고
rely on modeling and simulation,
방법을
conduct ground and flight tests.
가장 베스트하고 옵티멀하게
to come up with the best and optimal
검증하느냐.
solution and ensure safety.
그래서 현재까지 작년까지 저희가 연구
So until last year,
보시는 여러분들이 보시는
we have achieved some results, and these are what you're looking at.
MOC를 추가한 MOC와
Means of compliance,
믹싱에서 만든
technology standards are added here.
위한 최상의 버전
So the
도큐멘트인 CCL
compliance checklist,
리스트를 포함해서
it is
작년에 모두 완료를 했습니다.
it was completed last year, but we are working on it further
지금 현재
to improve it,
정부 과제의 산출물로 정부에
and this will be
제안할 그럴 계획을 가지고 있습니다.
provided to the government as one of the deliverables of this
여기까지
project.
이제 제가 이제 우리 미래에 2030년대에 우리의
In 2023, UAM will be introduced to the public with fully autonomous
기술 기준을 마련하기 위한
aircrafts.
과제와 성과를 말씀드렸습니다.
And the government has been working on it with the project to come up with the standards and certification process.
어떻게 풀어야 될 것이냐.
And now we still have some
우리
challenges to address.
안전기술원과 워킹 그룹
KIAST working group members are working together
연구 결과를 제시하고
to plan research results,
이러한 연구 결과를 통해서
and if necessary,
항공안전법 시행 규칙 레귤레이션
the current Aviation Safety Act,
방금 내가 말씀드린 드론법
enforcement rules, drone rules,
UAS를
and others
수 있는
will be amended
연구하고 살펴볼 계획.
for full implementation of UAM.
정부 부처인
Related government bodies such as MOLIT
그럴 예정으로 갖고
will be advised with proposals for amendments.
스탠다드에 대해서
As for certification standards, we are also going to make
그리고
an implementation action plan.
과정에 필요한 8개 핵심 요소
8 core
뿐만 아니로
technologies
추가적으로
and additional
되는 핵심 기술이 있다면 이에 대한
technologies
인증 기술
to be identified
실행 방안에 대해서도
will be submitted along with their action plans.
예, 목표이고
That's the goal of our project.
마지막으로는 또
Lastly,
밸리데이션, 베리피케이션 할 것인가
how we are going to validate or verify it, we need
적극적으로 연구가
continuous
필요한 내용이 되겠습니다.
study on it.
결론입니다. 예,
So conclusion,
저는 이렇게 생각합니다. 가장 중요한 거
I believe
그리고
acts and regulations
이
comes
뒷받침
first,
하는 것과 그리고
and certification standards should support it,
우리나라만의
and Korea-specific
기준의 재정 수립
technology standards should be identified and established,
확인할 것인가
and we also need a method of compliance for them.
미래 정부에서 목표로 하고 있는 2030년대에
So by 2023, the government aims to introduce UAM to the public,
이용할 수 있는 일상생활의
and through our project, we hope we can make changes in UAM with the introduction of such service. So that's all for my presentation. Thank you for listening. And if you have any questions, I welcome any questions. So in the panel discussion, if you ask me the questions, I will answer them.
남궁평 책임님께 큰 박수.
Please give him a big round of applause.
개인적으로 같은 공간에
Personally,
매일 뵙거든요.
I see him every day in the same office, and he's such a passionate person. He's always full of energy. And yes, I can see that.
어른이십니다.
So he is a huge contributor to our organization.
인증기술 연구회 대회가 올해 활발하게
I hope further
진행될 수 있는
advancement
좋은 성과가 있기를 바라겠습니다.
and good results of your hard work this year.
네, 우리나라 항공 보안 장비 인증 제도와
So our next speaker is Mr. Park Han-jun of KIAST, who will deliver his presentation on Korean AFSEC equipment certification system. Please give a warm welcome to Mr. Park.
네, 안녕하십니까. 다음 발표를
Hello everyone, I am Park Han-jun of KIAST. I'm working at the Certification, AFSEC Equipment Certification System Office. So our previous speaker has briefly touched upon the UAS certification projects and standards. And I'd like to talk about AFSEC Equipment Certification System in Korea. So this is how I will proceed with my presentation. First, I will briefly introduce you about the Korean certification system about aviation security equipment and related roles and responsibilities of our institute and what we have been achieved so far. So first, let me briefly tell you something about the AFSEC Equipment Certification System. This certification system in Korea has been in effect since 2018. As you know, the Korean AFSEC equipment, most of these kind of equipment are imported equipment. They are coming from overseas. But as the technology for the local equipment has been advanced, more and more locally made equipment have been adopted at the airport, and that is why we are making a lot of efforts for the advancement of the Korean AFSEC certification system. It has been more than 10 years that the advanced countries such as US and Europe have been established their AFSEC certification system. So, compared to those advanced countries with relatively developed AFSEC certification system, Korea has much room for improvement. But in Asia Pacific region, Korea is doing very well. So this is how the Korean certification system is organized. There's MOLIT, which is a certification authority, and there's KIAST, which is a certification institute, and there's Korea Testing Laboratory, which is a testing institute. So MOLIT is involved with overall operation of the certification system. For example, it is also involved with enactment and amendment of the related laws and regulations, and it is also involved with designation, management, and supervision of the testing laboratory. And KIAST is a certification institute. So the KIAST is conducting certification reviews, and it also issues certificates, and it also review and approves the performance test results, and it also conducts audits the manufacturer quality system, and we also support and we are involved with international cooperation as well. And the actual, we are also, as I've said, we also carry out the test performance. There's the testing institution called KTL, which performs the AFSEC equipment performance evaluation test, and it also seeks to improve test procedures and methodologies. And there's two certificate management activities. First one is performance certification, which is done first. So this performance certification applies to manufacturers of aviation security equipment. So these AFSEC manufacturers submit applications with our institute per model, and their equipment will be reviewed by the performance committee for approval. And on the right-hand side, there's another type of activity under the certificate management, which is performance test. And this performance test applies to equipment operators. And this is designed to extend durable time for 8 FSEC equipment items that are currently being used at the airport in Korea. So the equipment operators submit applications for the performance test with our institute. And the maximum year to extend the durable time is 2 years. So on the bottom of the screen, there's a procedure for certification from step 1 to step 5. So there are 5 steps for the certification procedures. This procedure is for performance certification. So for the procedure for the performance test, you only need to exclude one step. So the biggest difference between performance certification procedure and the performance test is that performance certification is for manufacturers, whereas performance test is for equipment operators. So for the performance test, we only carry out the performance test for existing equipment. So these are the 8 equipments that we are carrying out the test, so ranging from X-ray screening systems to metal detectors. So
연한을 뜻하고 있습니다.
and it also shows in the bracket you see the number of years, and that describes the the durable time for each model. And next, I'd like to touch upon roles and responsibilities of our institute.
먼저 왼쪽 상단부터 시계
So,
방향으로 설명을 드리겠습니다.
I'm going to start from the top left corner.
성능 인증인데요.
So the first activity that we are involved in is performance certification. We directly communicate with the equipment manufacturer to carry. So these equipment developer or manufacturers contact us and they submit application with our institute for performance certification, and then we inform them of the necessary procedure, including the cost. And KIAST also carry out performance tests, and after we conduct the test to assess the quality of the equipment.
장비에 대한 성능 평가를 시에
The testing lab carry out the test on the equipment and in the presence of our experts. And based on the result of the test, the KIAST committee comes in to approve, to make a final approval on the equipment. And next, I'd like to move on to the performance test. So this performance test,
을 취합 중에 있습니다.
so we collect the status of the usage of all the FSEC equipment that are currently used at the airports across the country every year. So I collect information on how many years each item has been used, etc. So we receive applications for performance tests for these used equipment to extend its service life. And there are standards for that performance test. Just like the standards for performance certification, the standards for performance tests are specified by the government.
말씀을 드렸습니다.
So these are 2 big tests that we are carrying at our institute. And we are also involved in projects to support the R&D of novel high technology based equipment.
하고 있습니다.
And we are also involved in developing the standards of Technology for Certification in collaboration with MOLIT. And as I've said, we are involved in projects to develop standards, and we are also involved in expanding collaboration with overseas institutes. So these are four big roles of KIAST.
다음 페이지는 저희 이제 항공보안 장비 시행 5년차 동안
And
성과에 대해서 간략히 말씀드리겠습니다.
next are our achievements so far.
신청 건수는 5건이고 현재
So we received 5 applications. If you look at the first and second column, there's manufacturer A and B. And you can see what kind of equipment that each manufacturer has applied their application for.
현재 검사 진행 중에 있습니다.
So the first two items, the certification process for the first two items has been ended, while the rest 3 are undergoing.
이 제작사는 다시 엑스레이,
So
엑스레이를 저희
the third one is the X-ray for cabin, and the fourth one is ETD, and the last one is X-ray for cabin, which is also ongoing.
인증심사위원회 심의를 올리는 부분이
So,
4번이라고 볼 수 있는데요. 4번에서 심의를 올려서 최종 억세되면 이제 인증서 발급을 하게 됩니다.
So you can see at the bottom of the slide, you can see 5 steps that we carry out for performance certification. So as
테크놀로지한 이제 기술적인 이슈
there are
이제 예를 들 수 있겠습니다. 하지만 이제
some
그것들이 다 보완이 되고
fail
앞서 지금 뭐
at obtaining performance certification. In that case, they try again and they make they submit, they reapply for their performance certification. And let's move on to the performance test achievements. We had started our task for the performance test since last year, and since last year, we have successfully performed these kind of performance tests for the used equipment at the airport or other operators. So as of last year, we have received application for LEDS and AIT, NSSC, which is shoe scanner.
각각
So our
방문을 한 다음에 입회하여
inspector
내용 연수 연장에 대한 평가를
or
진행을 하였습니다.
participated in the review process for the performance test.
지금 현재 하고 있는 업무에 대해서
And
간단히 말씀드리겠습니다.
next is R&D achievements.
R&D에서는 크게 세 파트로 분류가 되어 있습니다.
Our R&D activities are largely divided into 3 sectors. One is development, second research, third collaboration. So as for the development, we are involved in the development activities for test material, test kits, and certification management system. For example, we are in the process of developing test materials for better our system and to better our test kits to detect explosives, for example. And we are also in the process of developing certification management system. And next is research R&Ds. So our institute is also developing test methodologies, and we continuously support the modification and revision of related laws and regulations. That is why we are making significant effort in research activities to do so, especially related to security system technology. And we are also involved in doing R&D to support aviation law and regulations. And the next is collaboration. We collaborate with equipment manufacturers. We also collaborate with operators in airport and air cargo sector, and we also collaborate with international certification authorities. And as for our collaboration with equipment manufacturers, we have a meeting with them annually to further the collaboration. And we also collaborate with operators in airport and air cargo sector. And while collaborating with them, we collect their opinions. And we also identify and look for the current status. And we also carry out international collaboration. And we plan to further our collaboration with the International Certification Authority. And we are nearing concluding our agreement. And after this agreement is concluded, we will be able to carry out joint projects. So these are three R&D activities that we are involved in. Let's move on to the last part. So as you know, today's event is for the AAM, and we are also involved in improving aviation security for AAM. Last year, we had conducted research in three parts: qualifications, screening, and standard last year. And these three areas are closely related and connected in our project. As for the qualification,
운영하기 위한 보안 검색
it involves qualifications for UAM operators, the UAM operators requirements, and UAM. We have identified UAM operators requirement and UAM operator qualification standards. As you know, UAM, we expect that UAM will fly from city to city. That is why we believe that rapid screening system will be required at Verti hubs. That is why we have carried out this research project in developing rapidly screening system in Verti hubs and screening system as well. And we have also studied and researched standards for the screening technology for passengers, and also we have also conducted studies and research on UAM cybersecurity standards.
그리고 마지막 페이지 이제 이거는
And this is for your reference.
현재 저희가 이제 항공보안
At the moment,
인증제도 시행을 하고 제가 이제
as you know, we are involved in AFSEC equipment testing and certification process, and we have received, with the support from the MOLIT, we are currently conducting a project.
시험원에서 지금
Our institute is a leading institute in this project, and we are involved in this project to develop the National AFSEC Equipment Testing and Certification Center, which will be completed in 2023, which is next year. And when that center opens next year, we believe that we can take our AFSEC sector to the next level. With this, I'd like to wrap up my presentation. Thank you so much. Thank you so much, Mr. Park Han-jun from the KIAST. And as I have briefly mentioned to you before, security is of utmost importance, but there are other important factors as well to better our UAM system. And I believe the AFSEC equipment certification system is also considered one of the important factor.
Let me introduce the next presenter. The journey from UTM to UEM will be presented by Amit Ganju from ANRA. He is joining us virtually today since he couldn't come in person for today's event.
Hello, good afternoon, good morning, good evening, everyone. Can everyone hear me okay?
Yes.
Awesome, thank you. It's good to be here, and I thank ASTM, MOLIT, and KIAST to give me the opportunity to share with you guys a little bit more about what's going on in the world of standardization as we talk about US traffic management and its evolution to UAM. Before I continue, just to give you a quick introduction for those of you who are not familiar with ANRA, I'm the co-chair for the ASTM F38 working group, which is focused on UTM UAM standards, and I'm also the CEO of a company called ANRA Technologies. We focus as a company focus on airspace, mission, and data management for US. We've been in existence for 6+ years. We've been there since the day one when the term UTM was coined back in the NASA labs at AAM, and we're the only company that can claim to have been there since day one. So today, fast forward to today, we are a fairly global company. We are headquartered in Washington, D.C., where I'm based out of today. I'm talking from. We have offices in Asia, Europe, and UK as well. I'm not going to go through all the dots, but it just kind of shows you some of our engagements around the globe. In addition to being a technology provider, we also champion and work extensively on policy, regulations, and standards. I'm on the board for something called the Global UTM Association, the ICAO Trust Framework, ASTM we talked about, whether it's FAA's Rule-Making Committee, and so on and so forth. So we as a company, we look at it slightly differently because there are three aspects. If you look at the figure in front of you, there are three distinct aspects that need to come together in our view for this new form of aviation to become a reality. There's the technology aspects, but very important, a lot of times it gets left out and people don't focus. People start building technologies, but they don't realize that it's standards, regulations, and technologies that all have to work together in cohort. And if you look at this Venn diagram, this intersection point right there in the middle is where, if everything lines up there, that's the formula for success. And we as a company tend to work and focus on that area. We work on the technology side. Obviously, we are a technology provider. We focus on standards as well on the regulatory side, working on policies with the likes of FAA in US, with Swiss FOCA in Switzerland, with CESAR and other engagements in Europe, as well as in Asia or UK and other places as well. And what I'm going to talk about phased standard development. And what I mean by that is, if you look back a few years, we started with these small UAS, but where we are headed, and the topic of focus today is urban air mobility or advanced air mobility. We are talking about these flying cars. We have to look at a phased approach because the way you look at airspace management today, or if you look at the traffic today, and the previous speakers touched on it too, at any given time, there are, give or take, there are 10,000 manned or crewed aircraft in the sky at a given time. But when you transition to the uncrewed space, there are going to be hundreds of thousands or millions of aircrafts eventually in the sky. So the same paradigm that has been in operation for over 50, 60 years, managing air traffic, doesn't necessarily scale. That human in the loop paradigm doesn't work. So we have to move more towards human on the loop kind of paradigm. So from that point of view, you need to have different actors in the system that take care of various aspects that are required to make this thing a reality. So if you look in terms of what is required from an airspace management point of view, whether it's UTM and transitioning to UAM, and I'll touch on that a little bit more, how the evolution is happening from where we are today to where we need to be. You look at these 8 pillars. This is not a standards thing. This is something, the way I like to share, I call it the 8 pillars. Like, so you have aspects that you need to handle, like the aircraft data exchange, your airspace awareness, your strategic separation, tactical separation, emergency management, monitoring, environmental factors, and ATC interface. All of these have touch points, and unless you touch all of them and have integration points into all of them, you are not going to be able to build and deploy a scalable ecosystem for all these things to happen. So first, I'll touch on a concept called Uss Interoperability. And Uss is an acronym which is called UAS Service Supplier. In US, that's the terminology that's used. If you move to Europe, they call it a U-Space Service Provider. If you move to UK, they call it the UTMSP. So they're different terms, but at the end of the day, it's an entity that is, or a service that's handling traffic management for low altitude airspace operations for UAS. And as I mentioned, the paradigm changes how we are used to handling air traffic management from a more centralized monolithic approach. It moves more towards a more federated, where multiple actors which are working in cohort, working together and sharing data sets to make sure that we can still maintain the safety of our national airspace system. So the first thing in our crawl, walk, run phase, because as you looked on those 8 pillars, there are a lot of complex problems to solve, and we can't just solve them overnight and have a solution that works out of the gate. So we have to use like baby steps and do incremental dev cycle. And I'm sure most of the folks on the call are familiar with, like, when NASA started this research back in 2015, there was something called the TCL campaigns, TCL 1 through TCL 4, and from the UTM, and now it's UML 1 through UML 4 for the national campaign, Advanced Air Mobility, Urban Air Mobility campaign. Then FAA had UPP1, UPP2, and then now you transition to Europe, where we are engaged similarly like NASA with CESAR and other entities in Europe. You looking at different use-space use-space iterations. So in the crawl, walk, run phase, when we are looking at the standardization, because what we didn't want to do is have everyone go out there and look at a black box solution and build these stovepipe solutions which are not interoperable. And I like to use an analogy which people may relate to. If you look back 15, 20 years and you pick up a cell phone in Korea and you went to US, your cell phone stopped working. Or if I went from US to, say, Japan, it stopped working because there were different technologies. There was CDMA, GSM, then and Japan had PDN, other technologies. So they were not interoperable. And you had standards bodies like 3GPP2 and 3GPP, eventually 3GPP1, and everyone moved on to the LTE bandwagon. And then from LTE, we moved on to 5G. And so today, if you fast forward 15, 20 years, today you pick up a phone and you go anywhere, your phone continues to work because the systems are interoperable. That shows you the significance of interoperability and the standards. We kind of use the same mantra, and that's how we started working on this initial scope of the standard. So we said, hey, what are the bare minimum things we need to do to get something out there operationally that we can test, integrate, because we can do a lot of paper drills and start writing stuff, but till you try things out in the field, you don't know what the faults are, what works and what doesn't work. So in terms of the initial scope of the standard, and as I go through it, I don't want people to feel that, hey, this is just a small part of the problem. This is just version 1 of the standard that we touched on from an interoperability point of view. So we focused on something called strategic coordination or strategic conflict detection and constraint processing and constraint management. And what you see on the right-hand side is this is the function of a UTM or a USS. And then there are other USSs in the area. So USSA may be covering particular customers in one area, but there's a USSB that is covering a different set of customers, but in the same airspace. So they have to be able to share information, operational intent, and deconflict. And then you always have the interface towards the operator, and then constraints like, hey, if dynamically, in addition to the static airspace constraints, if you need to change some of the constraints in the airspace, like a dynamic no-fly zone because there was an incident, a protest happened, or a wildfire, how do you manage those kind of things? So moving on, so one of the key paradigms we had to solve here is how do we, when you have these now, instead of one monolithic entity, you have these multiple entities that need to work together. How do you make that happen? How do you do that? So a couple of concepts we had to work on. The most important concept was discovery and synchronization. And you'll hear me talk about this term called DSS. So DSS is, it's an entity, think of it as a logical entity. So if there are multiple UTM providers in the area, it will tell you who do you need to talk to if you're planning operations in an area, and then making sure that you do talk to them, and then also tell you the means by which you talk to them. So think of it as a phone book. A phone book gives you the phone numbers. If you look at a person, it gives you the phone number, and then you call that person directly. The same paradigm. So if you were to look at a pictorial depiction of this concept, the DSS is airspace, a shared airspace representation, the common truth, which tells you what's happening in the airspace. So if there's a USS A and a USS B, so USS A wants to plan an operation in a particular area, they will go to the DSS and check if there's someone else in the area. DSS says there's no one, for example. And they will come back, plan an operation, and put a pointer in the DSS, not the whole operational intent, and say, hey, in this particular grid, I have an operation going on, or maybe in these two grids. And then a USSB comes in and they want to plan, maybe their operation intersects with one of the grid cells that USSA has. So when they go into the DSS tells them, hey, based on what you're sharing, you need to talk to this USS. And then after that, there's a peer-to-peer exchange that happens between the USSs, where USSB goes to USSA and tells me, and asks, hey, I'm planning an operation in this area, and I realize you have an operation here. Can you share the operational intent details with me so I can deconflict and plan my operation around you in 4 dimensions, which means space and time. So I oversimplified it. There's a lot of intricacies there, but in the benefit of time, I just wanted to talk about the concept. So if we kind of peel the layers a bit further, so if we look at an example where there are 4 grid cells, so let's say there are 3 USSs involved, USS1, USS2, and USS3. USS1 has an existing beyond visual line of sight operation, which goes from A to B to C. So in essence, it's touching 3 grid cells. So DSS knows, hey, USS1 has touch points in these 3 grid cells. Then you have a USS2, which has a localized existing visual line of sight operation in that blue circle you see. So now a USS3 comes in and wants to plan an operation from X to Z, and we'll call it, let's say, a planning area, this purple thing. And once it queries the DSS will tell it, hey, based on what your area of interest is, you need to talk to USS1 and USS2 both. And that's in essence what it's going to do. It's going to talk to USS 1 and 2, get the operational intents from both of them, plan a deconflicted operation, and in essence, put an operation that is deconflicted with both of them. Now, it's a little confusing because this is a 2D view. It looks like the purple one is intersecting the red one, but it is actually not. It's separated in altitude, so it's stratified. So it's maybe above or below it, so it's not necessarily intersecting. So they're all deconflicted in space and time. And that's in essence what it was when we say strategic deconfliction, pre-flight deconfliction. So that's the basic paradigm, one of the basic paradigms of this interoperability standard. I'm also going to touch on another concept. Now, there are other concepts like constraint management and stuff, but I'm going to skip that. I'm going to focus on remote identification, and then I'll talk about how these underlying concepts, which were originally created for UAS traffic management or UTM, are now being evolved for UAM, because that's the primary focus here. And we have seen it because we've been involved in UTM, we are involved in UAM in multiple places around the world, so we can see that transition, because there are some concepts in the UTM that work fine for low altitude, but doesn't necessarily work fine when you move to AAM and UAM. So there are new paradigms that need to be introduced. But before I go into that, let's talk about remote identification a little bit. Remote identification, or electronic conspicuity as you talk about it. So what I was talking about so far was the UTM standard, which has been approved and it's getting published here in the next few days. In addition to that, there's another ASTM standard for remote identification, which relies on both network and broadcast-based means of what you call remote identification. So one relies, if you don't have any network connectivity, you're not connected to the internet, you're just in a localized area, it supports Bluetooth and Wi-Fi based remote identification, where there's a transmitter on board the aircraft, and you can use a smartphone, as is shown here on the right hand side, like a smartphone app, which using a Bluetooth or a Wi-Fi link, and if it's Wi-Fi, there's a new there's a stack in Wi-Fi called neighbor-aware networking or Wi-Fi aware. It's not your typical Wi-Fi access points that people are generally used to. It's a different modified version of that, which is in line with the standards, which lets you detect the drone and then track it and get the identifiers associated with the drone. So a law enforcement official or any other stakeholder that is authorized can track the drone. So if you step into a backyard and you see a drone flying there, how do you know it's an authorized drone and not a peeping Tom? So a law enforcement official can come in and play there. Now, this paradigm works locally, but now if you move into more like BVLOS operation kind of things, when you're going miles and miles, by the time you pull out your app and try to detect an aircraft, it may have already gone outside of the Wi-Fi range. So that's where the network-based remote identification comes into play. And this is this is a system like in Europe, Swiss FOCA has already deployed a nationwide voluntary network remote ID system, and we are one of the providers there, and others are too, because it's standards-based and interoperable. But this paradigm relies on network access, whether it's cellular or any other network, and it relies on the USS. So the operators are registered with the USS. US is tracking their position, and multiple USSs are tracking their respective UAS, and then there's an entity called display provider, which aggregates this data from various service providers, as you see in this figure, and then a display app. So if you're interested in a particular area and there are multiple UTM providers operating in that area, and you want to do a you want to remotely identify a few drones in that area, the display app can go to the display provider, and display provider will, based on the DSS, the discovery service, find out what are the service providers in this area and query them for that geographical area and get the relevant operations back and make them available on the display app. This standard also allows non-equipped aircraft to participate too, where like RC, a hobby aircraft, could declare an area that it's operating in. There'll be no tracking, but they can declare an intent and say, hey, I'll be in this area. So that's another low-cost means of not allowing non-equipped network participants to participate in this as well. So I'll skip this. So in the best essence of time, I'll talk about, so I talked about the things that have already been done and are out there, and I'll be happy to, if anyone has any questions, they can reach me offline. I'll be happy to point you to more information. So I talked about the basic concepts, but some of the future work items that have been identified based on the crawl, walk, run methodology is how to reevaluate the assumptions around the construction of operational intent, which is the volume which we define when a drone is going from point A to point B, creating a volume that it's going to stay in 4 dimensions, space and time. Looking at negotiations, which kind of also touches on priority-based operations. So if there are conflicting operations, how do you negotiate between them? How do you handle fairness and equitable access of the airspace? That's a very complex problem to solve, as you can imagine. Then looking at additional means of conformance monitoring, advanced constraint management, handling privileged users. One of the key things to do is handle is auditing. How do you know there are no misbehaving actors in the ecosystem? So, and if a UTM system goes down or a discovery service goes down, how does it impact the airspace management of that particular area? What are the fail-safes that need to be put into place? A few areas that we are looking in our subsequent version, which has just been kicked off. Some of the examples are limited manned aircraft integration, looking at one of the key things that the standard, and this work has already kicked off, and I'll touch on that in the next couple of slides, is UAM commonalities, what do we need to do? What are the gaps in the existing UTM standard that we need to address to move into the UAM aspect? And any enhancements to the DSS. So let's look at the UAM related activities. So we are building up on top of what's called UTM, and you'll hear me use a new term called PSU, which is the provider of services for UAM. And PSU is essentially the new name NASA coined and FAA coined for the next version of the UTM system, which is designed for advanced air mobility or urban air mobility. So some of the things, and these are part of the same working group that I co-chair. And we are looking at what are the different functional roles that PSU plays. What kind of interoperability does it need to handle? It needs to interoperate with other PSUs. It needs to interoperate now, which was not required for the UTM standards, with the Verdeport and the Verdeport infrastructure, with authoritative resources, and in some cases with UTM systems as well, when it's operating in a mixed use airspace. And some of the concepts that also evolved from the UTM to the UAM world are now, instead of focusing on purely volume-based operations, moving over to trajectory-based operations and handling things like corridors, handling things like demand capacity balancing, handling things like merge points. How does that change the strategic deconfliction model? And the work is already ongoing, and as part of the NASA X4 and also the work we are doing with MOLIT in Europe, some of these concepts are actually getting exercised, and the standards are being built collaboratively. So it's not just us. There's a team of like 20, 30 folks that are part of this working group that are working towards different industry participants, regulators, and research entities that are working on these standards. Here's a nominal gate-to-gate. This comes from the NASA ConOps, and I'm sure many of you have seen it. So it talks about the responsibilities, where do the responsibilities lie, and the operator versus air traffic control versus PSU. And these slides will be available if you don't, if you guys would like to look at this in detail. But you'll see there are different phases we are talking about here: pre-flight versus takeoff, versus climb and cruise, versus descent, and land and deplane. And the different actors, whether it's a fleet operator, whether it's a PSU, whether it's a regulator like the FAA, whether it's the Verdeport operator and the vehicle. And each one has different touch points and roles and responsibilities. And in essence, digital exchanges. What it all boils down to is there's a lot of digital exchanges that need to happen between various actors. And there's always going to be a human in the loop in some shape or form. But a lot of these, which were traditionally voice comms and stuff like that, now start transitioning to digital exchanges. This is, I believe, my last slide probably. What's going on in the group currently. So we have a focus group within the group that has already identified gaps from the UTM standard and is working on filling those gaps, because we are starting to exercise those concepts as part of the NASA X4 campaigns and the European campaigns as well. And so if there are folks that are interested, ASTM always welcomes international. We have a lot of international folks that participate. So please feel free to reach out to me. We would love to pick your brain and get you engaged in any of the working groups you might want to contribute in. Here's an example just to show you how it's different than what we were doing in the UTM world. Now you have this concept of a corridor around a vertiport, and as multiple aircraft are coming in to land at that vertiport, and depending on the number of land sites, you may have a merge point from where the corridor starts. So all aircraft come using strategically deconflicted path till then, and then they go to the merge point, and from there they get slotted into a corridor, one behind the other, to go into the landing sequence. So some of those concepts and how that handles the demand capacity balancing, and how do you handle prioritization and things of that nature. I kind of rushed through the whole thing, and I think I just went a minute or so over my allocated time, but it's been a pleasure talking to you guys. Happy to answer any more questions. Here's my contact information. Thank you for letting me speak, and 감사합니다.
네, ASTM의 간주님께 다시 한번.
Thank you so much, Mr. Amit Ganju from Enra Technologies. Thank you so much for your insightful presentation. So we are having this opening the early morning session in Korea, but our overseas speakers and participants joining us at night because of the time difference. Thank you so much for joining us and delivering such a wonderful presentation. I hope better in the future we will have more close cooperation among us. So for next presentation, allow me to introduce our next speakers who have joined us online today, Mr. Jonathan Daniels of Aerospace Concept International and Mr. Rex Alexander of 5 Alpha will give us updates on Verdeport standards.
발표해 주시겠는데요. 네, 한번 온라인으로 만나보겠습니다. 여러분 큰 박수
Please give them
부탁드리겠습니다.
a big round of applause.
Hello, Mr. Jonathan Daniel and Mr.
Good morning.
Rex Alexander.
안녕하세요.
Oh, thank you for joining us. Please go ahead.
Wonderful. So again, thank you very much for inviting us to join, and very happy that we're able to do so even through such remote setting. Rex and I are very pleased to discuss Verdeport standards and technology, provide an update on where we are on some of those standards right now. Next slide, please. Oops, hold on. No problem. So by way of introduction, Rex and I both serve on F38, which is the ASTM Unmanned Aircraft Systems Committee. I am the committee chair subcommittee chair rather, for F3803, which is organizations, personnel, training, and certification. But by nature of my professional background, Rex and I also run the Verdeport standard together. We first organized that standard in 2017 and have run through 5 separate balloting efforts for date, with our 6th revision that is entering balloting process right now. A couple of items to discuss related to that standard, and a lot of the challenges is some fundamental differences between how the United States and Europe and other nations handle the commercial versus private use aspect of vertiports, as well as the interesting forms and platforms that are available for vertical takeoff and landing aircraft that are so radically different and not commoditized the way helicopters are. One of the nice things about helicopters and heliports is they all kind of look the same now, but the eVTOLs are very, very different. And there's something to the effect of 600 different styles of eVTOL that are out there, and trying to create standards and harmonize that is turned into a much longer process than I think Rex and I envisioned. Next slide, please. Tapping into an ongoing development as well, much like Mr. Ganshu talked about, is what we call the Verdeport Automation Supplemental Data Service Provider Standard, which is an identified component of the UTM and PSU systems, where those outliers that Verdeport would contact and talk to the PSUs from there. Now, this was organized only last year in the summer. It was based on the completion of some NASA high-density Verdeport automation software research and development that Rex and I participate in. We're going to talk about a little bit more about that later on in the discussion. It is aligned to our standard on the development. So if you think of it as the first standard is more hardware focused and the second standard is more software focused, that's how that relationship is. And one of the things that we're sliding into the Verdeport SDSP happens to be compatibility with some of the 3GPP release 17, which is due this quarter of this year. Next slide, please. And last on this, on the standard side, is F39, which is our Aircraft Systems Committee, is developing a practice for autonomous aviation systems. And one of the things that we've discovered is we need to work and link all 3 of these standards together, so that as we evolve simplified vehicle operations and more of the advanced aircraft themselves, and start separating functions away from pilots and operators and into electronics and automation, that we have them connected, and some of that broadening of the autonomy, in fact, goes to the infrastructure like vertiports as well. Next slide, please.
Thanks, Jonathan. As Jonathan said, we've been working together on the ASTM process for almost 5 years now this summer. So it's not something that we just started yesterday. One of the other complementing efforts out there is in fire code, and that's one of the areas that I specialize in. So the National Fire Protection Association, also known as Nfpa, is adopted standards in over 50 countries. There is a current NFPA 418, which is heliport standards. In the last iteration, we actually added vertiports as a term, as well as vertistops. And that was published in January of 2021. As soon as that was published, we immediately opened up the discussion to move forward to advance fire standards for eVTOL aircraft. And in doing so, we reduced the time that the 418 standard is normally revision cycle. We went from 5 years down to 3 years. And what that meant was we started immediately in 2021 of April in advancing this next generation of eVTOL standards. It will live in NFPA 418. We've had several meetings over the 2021 summer, and now moving into 2022, our next major meeting will be in April. We have 5 days scheduled the end of April, plus 2 additional days the first part of May. We received 88 public inputs, which I think is a record for NFPA. I'm not 100% sure, but out of that, we're going to then publish the next post draft in October of 2022. That then opens up public comment period. That closes in January 2023. And then the second draft will be posted October. And then in 2024, we're looking for a final document with potential adoption by 2024. So NFPA, National Fire Protection Association, is recognized by the ICC, that's the International Code Council. So International Building Code and International Fire Code both point to this standard. And one of the key elements we're working on in this with ASTM, as everything else, is harmonization, and trying to make sure that everything we do is harmonized across the board to the maximum degree possible. Here in the United States, the Federal Aviation Administration has been working diligently to begin the process of developing standards for vertiports. We have heliport standards. The first heliport standard was developed in 1959 and has gone through several revision cycles since. The standard for vertiports will live in what we refer to as an advisory circular. The advisory circular is developed and published by the Federal Aviation Administration for U.S. adoption. That process started in 2021, and we expect to hopefully have a published advisory circular for vertiports in 2024. In the meantime, to provide guidance for any manufacturer who is able to get certification before then, the FAA will be issuing what they refer to as an engineering brief as a stopgap measure to address standards for eVTOL aircraft. This month, February, is what they have pointed to as the release date for an engineering brief. In March, the 7th of March, at the Helicopter Association International's annual conference, which is called Heli Expo, we will have a industry meeting to review and discuss that engineering brief. On the 29th of March, the FAA will then have an industry day to then vet that discussion, and by June they look to publish their engineering brief. That will live and provide guidance until the advisory circular in the United States is then published. Another group that's also working in this space is EASA, the European Aviation Safety Agency. In June of 2021, they did publish draft document that talked about the eVTOL or vertiport design. That's the second publication, a proposed means of compliance with special conditions in VTOL. I included the website at the top of the page. You can then go and look at that. Now, EASA is also working with the International Civil Aviation Organization, ICAO, which publishes heliport standards under Annex 14, Volume 2. We're working with EASA and ICAO, again, to try and harmonize as much as possible. The other group in the United States is working very diligently in this space is the NASA, our National Aeronautics and Space Administration. You can download the information that I'll show and John will show from the website that I have there on the right side. In a white paper that was published last year, we looked at the different possible geometric shapes for vertiports, as well as all the different possible outlines of vertiports. On the left is a very standard, traditional straight throughput with a landing and takeoff area, the TLOF and the FADO and the safety area on either end with parking in the middle. The figure on the right is a larger design with 4 independent landing areas, 1 on each corner, and then surface parking in the middle. In looking at what that meant, one of the things we looked at was the wind considerations. In developing the white paper, NASA had looked at the different feasible approach and departure paths. For helicopter operations, and same for fixed wing operations, downwind operations are to be avoided. It's much more challenging from a performance standpoint and less controllability. So in evaluating the different wind conditions, we looked at what was possible, what was probable, and what was recommended as far as avoidance. These are just a few of the graphs from the white paper that was published. And then in looking at the approach departure paths and how they connected, the other piece was looking at what was the maximum possible throughput for traffic that we could potentially get. And in doing so, the 2 images in the middle are the ones that provided the highest throughput based on the mathematical calculations that NASA worked on in this particular case. These are what we would refer to as UML4 considerations. And now I will turn it back over to Jonathan.
Thank you, Rex. So as I had mentioned, NASA funded a high-density automated vertiport research project. And that project was composed of 4 different sections: a trade study, a concept of operations, a software requirements matrix, and then some additional actual software development pieces that have turned into the basis for our SDSP standard. And what they were really designed was taking a look at, as Mr. Ganchu had talked about, the existing UTM work and how vertiports came in, and the idea that if there are UTM corridors or UAM corridors for our eVTOL aircraft to be flying on and be deconflicted off of, at some point you have to enter and exit those highways in the sky. And we looked at that as the base model, and then using the UML4, we applied it to a high density concept of operation. And high density was defined as 100 or more takeoffs and landings within 1 hour at a single vertiport. And as we look at that and started to build that out, much of the things that Rex just described, the challenges to the real estate size and the spacing and even some basic, just fundamental geography really became apparent to us. I would advise anyone who can follow the link that we provided earlier, and you can actually download all of these reports in their entirety. And it's definitely a very good read, several hundred pages of concept, and I'm going to try to talk through some of that here. Next slide, please, Rex. So the meat of what developed was the vertiport automation architecture. And that idea was that the piece that belongs at the vertiport, and it really had two different sections. One part of that was what connected to the PSUs and on the outward facing, and the other part was more internal and identified the requirements there for how you would track parking locations, ground traffic, taxi departure, and then all the contingency and off-nominal items that would occur. Additionally, one of the items that we discovered that I know we're going to get into a little more related to the sequencing of approach, because oddly enough, with 100 operations an hour, that means something is landing every 30 seconds or less, or taking off every 30 seconds or less. And that requires much more maneuverability and optimization than merely accomplishing that 30-second timeline. Next slide, please. So on the VAS itself, really tied into some basic core services to enable the functions that you would then provide, not just the management of vertiport resources, what pads were available, what type of parking, what type of refueling, but also to make sure that everything that is occurring on the surface itself was actually following the guidelines and procedures that were in place. So that if there was an aircraft that was running behind, or if someone dropped their luggage or something to that effect, or the passenger slipped getting into the aircraft, that all of that was captured in some way and able to be fed both locally at the vertiport itself, as well as transported out through the SDSP to the larger system for the PSUs to take out of. Did tie into our hazard conditions and our risk. It did very much highlight the need for a good situational awareness, as well as some of the limitations and potentials of autonomy. And one of the following items about external stakeholder communications was that notification outside the facility itself in the interest of an incident or some type of contingency, whether that was firefighting or rescue or even assisting with people who are not participating in the Evita PSU network. Next slide, please. I think one of my favorite pieces as a former helicopter pilot and something of a instrument approach aficionado, or as Rex calls me, nerd. One of the things we developed out of this was this concept of a vertiport operations area and then the vertiport volume. And you see that depicted here. The vertiport operations area is that larger blue-purple sphere and disc you see in place, while the vertiport volume is really on top of the geographical location itself of the vertiport. And as we developed this, we realized that in order to get the sequencing you need, you really have to have the outer spacing consolidated and federated in a way that it didn't matter which PSU was being used. It didn't matter if they were participants or non-participants, that we could feed them in together. And we started developing this dynamic, not a straight-on linear departure and approach pattern like we traditionally see with modern manned aircraft and traditional aircraft, but we call it the carousel approach, where picture those initial approach fixes on the outer surface rotating in time and not just being a single spot, so that as aircraft are cycling in, they're kind of working through this pinwheel pattern before they make their final approach and then enter into the point in space and final visual segment. And as you can see depicted on the right, that final point in space and visual segment is where they would break off and land at the appropriate landing areas. And this allowed us that final infrastructure of vehicle communications. Should something happen, there have to be an immediate move from pad 5 to pad 1. We could do that at that point very quickly and rapidly. Next slide, please. On that larger connection of how all this works, again, our idea was it only adjusted everything with the vertiports and the vertiport SDSP, really only tied in on the on-ramp and off-ramp into the larger UAM and AAM corridors. And once you left the corridor and began approaching your vertiports, that was where the vertiport operations area really began. And you can see some of that depicted here. Because once you've left the vertiport and you're outside, as was depicted earlier in Mr. Ganji's presentation, that is where the traditional air traffic control and traditional or rather newly developmental PSU integration and UTM really takes over, and we didn't want to have a conflict there. Next slide. And these are more pictures of how that worked and some of the things that we put in place. We realized that it's very easy to optimize when everything is accomplished well and there are no questions or concerns or sequences once you start putting in the sequencing issues and someone falls behind, or there's some crosswind or other unexpected items on the surface or in the air, you really have to have a very robust system behind that in order to make everything continue working smoothly. It's very difficult to tell someone no in an emergency when they're attempting to land an aircraft that is only have a minimal hovering capability and is kind of transitioned and committed to landing at that location. Next slide, please. This is a larger breakout and kind of describes the information that is available out there. Our trade study was when we talked to industry and gathered information on how the industry viewed the task of vertiport automation and where the ground truth and contemporary viewpoints were. We also, at that point, looked at the future work being done on the ConOps that were under development, and then started to develop that ConOps for how we would match where industry thought trade was, where the ConOps thought we were going, and what gaps we had identified in between. The final piece was the vertiport automation side, which you'll see a series of OV1s like I just described, as well as the systems views, all of which is available from the NASA site, as well as some systems-based or model-based systems engineering actual files that were designed to have that together. And as you can see, that now feeds some of the follow-on work, both with FAA, NASA, and how they're developing on the UTM, as well as NASA's additional ATMX and high-density vertiport discussions. Next, please. So that concludes our portion. Really appreciate you letting us speak. Very excited to describe this work. It was about 1.5 years of our work just on the NASA studies alone, and we're continuing actively. As Rex did mention, there are many things that are tied into this that are continuing, especially on the ASTM side. Very excited that the current ballot's going out, so that allows us to really focus in on the SDSP. Rex, do you have any closing comments you'd like to add?
No, thanks, John. There is a lot of work going on in the background. John and I are involved in quite a bit of that with not only ASTM, as I said, National Fire Protection Association. I'm actually the chair of 418 committee, and working with the FAA on several contracts, as well as NASA on a couple of other contracts. The one that John just got finished briefing was a stepping stone for the new one that just kicked off, which is automated air traffic control. So hopefully by next year, we'll have a brief on that as well. So thank you so much for the opportunity to speak to you today, and really appreciate everyone's time. Thank you.
네, 조나단 다니엘님과 렉스
Thank you so much, all the wonderful for your wonderful presentation. Let's give a big round of applause to our wonderful speakers. So last year we have briefly talked about a couple of presentations on vertiports, and we have just saw how actively ASTM is involved with developing standards for vertiports. So I wonder how vertiport standard will be developed in the future by ASTM. Well, our next speaker is also related with the ASTM.
The last speaker for ASTM session is Tom Gunnarsson from WISC. He will give us a presentation on Evita certification and AC433. Please give him a big round of applause.
네, 지금 탐 권학선님께서 준비 중이셔서.
I think he's getting ready for the presentation. Just wait for a moment.
지금 이제 여기 보니까 eVTOL 그리고
So it is about eVTOL and its certification. So I think I've been seeing this more and more recently. So eVTOL was also discussed yesterday. So I'm not sure what you're looking at on the screen.
포스터나 이런 사진 보시면은 그 안에
there is an aircraft picture on the screen. So this is the electric vehicle with vertical takeoff and landing capability. So this is electric vehicle using green energy. So this is about eVTOL certification. So can you elaborate on what is this certification about? So I think I can tell you more about it after his presentation. I'm not sure if he's ready yet, so he's still preparing for the presentation.
한번 어떤 내용을 설명해 주실지 들어보도록
Let's
하겠습니다.
invite
Hello?
him to the podium.
Hello?
Hello.
Can you hear me? Can you hear me?
I can hear you.
Oh, yes. Please go ahead.
Okay. Thank you for having me. And I'm going to take a little different scope in my presentation and talk about certification of the aircraft and some of the standards work that is taking place toward that end. Next slide, please. In ASTM, we have several committees that are working specifically on UAM, AAM, and eVTOL aircraft. As you can see here, F-37 is on light sport aircraft, F-38 is on unmanned aircraft systems, F-39 on aircraft systems, F-44 on general aviation aircraft, and F-46 on aerospace personnel. These are all committees that are aviation specific, and each one of them has some components that include eVTOL related standards. There are also some other ASTM committees that have some work that crosses over into that area as well, but they're more on the side. So these committees have been working for some time. In the case of the first one, F-37, it was established now 20 years ago. And since then, we've had the other committees be established to help develop means of compliance to new performance-based regulations in the US and abroad. Both F-39 and F-46 support those efforts. These committees are now jointly discussing how to share the activity, because we're beginning to have some crossover between each of the committees. I'm going to focus in on the specific aspects out of F-44 on eVTOL, where there were gaps in the standards. Next slide, please. So on the right is a list of standards that are being developed or modified to include areas where there is eVTOL specific language needed. So I won't read through them, but you can see there's a good number of them. And this is all under, mainly under F-44, general aviation aircraft. So F-44, its scope is the development and maintenance of standards and guidance materials intended to be acceptable means of compliance for general aviation aircraft rules and regulations around the world. It addresses the full spectrum of general aviation aircraft, and AC 433, which is an administrative committee, it doesn't create standards, but it oversees this activity. It updates eVTOL related work items across all of the different committees. Next slide, please. So this advisory committee was formed when there was an interest in making sure that the ASTM standards covered the areas that would be applicable to eVTOL. So there was a gap analysis performed against the Part 23 for FAA and CS 23 for EASA, needs of compliance, based on the new performance-based rules. And as you can see from the chart, the majority of standards that already exist covered what was needed for eVTOL. There were some that just weren't applicable, and there were some that needed some only minor changes, and there were just a few that needed major modification. So the focus then was on the list that we just saw of areas that needed to be created or modified. So there are a total of 23 work items, and this group, AC 433, both helps facilitate the activities of each of those groups and then monitors that activity. And if there are new things that are discovered that need work, those will be added as well. So this group has regular meetings about every other month to have each of the working groups report out, and then that information is shared with the rest of industry and authorities. Next slide, please. So here's a more real example of an aircraft that would fit into this category. It happens to be the aircraft that my company, Wisk, is developing. And you can see some of the areas that are being covered, such as fly-by-wire flight controls, distributed electric propulsion, electric engines, energy storage, etc. These are all things that require more than what we have today within the standards to be able to show means of compliance. Next slide, please. So with the development of the aircraft, as we've just heard about how to operate in the airspace, landing sites, there are many, many factors that need to be considered that are new and different than what we are traditionally used to in current aviation and operating in the airspace system. So we talk about this as an ecosystem for which there are a number of challenges. So I'm talking specifically about certification, so type certification, production approval, similar to legacy aircraft. But for these aircraft, we're going to, because we have some new areas to cover, we'll need to have special conditions, operational limitations. On the production approval side, some of the new technology will include additive manufacturing, high rate manufacturing. For airspace integration, especially as if we're talking about autonomous operations in the future, spectrum, C2 link, vehicle to vehicle and vehicle to ground communications, cybersecurity, uncooperative traffic and conspicuity, just being seen. On infrastructure, we just heard about vertiports. Charging is another one of those challenges. And then, of course, community engagement comes on top of all of that. So we need to have the local and city acceptance before we'll be able to operate in some areas. If we look at FAA and their expectations as this industry continues to develop, here's just a quick look at some of those. So in the short term, the expectation is that there will be a pilot on board and that most of the existing regulations will be met, particularly the operating limitations. that there'll be minimal new technology in aircraft, and there'll be low rate production and operation. So if we look at those who are talking about entry into service in, say, 2024, this will probably be most like what we'll be seeing. In the medium term, we're going to see approval for more automated systems on board, potentially remote pilots and operators, a hybrid airspace system where we're working with the UTM concept and developing that into something where we can have the integration of those operations with legacy operations, therefore a hybrid airspace system. As the public gets used to seeing these, the expectation is the acceptance level will come up and more routes will be able to be established. But the ultimate objective is full autonomy, operations at scale, costs similar to high-end ride share, and seamless airspace integration. So there are different approaches to this. Some of those who are wanting to enter into service sooner are looking at those short-term expectations. There are a few like Wisk that are looking at going straight to autonomy, which is certainly a challenge, but also just another opportunity there. Next slide, please. So ASTM has been very interested in autonomy and what that could entail to get there. So there was another administrative committee, 377, that was established to develop some documents, technical reports, to speak to this area, not create standards. Most say that's a little premature still. But so far there have been two publications, Autonomy, Design, and Operations in Aviation, focused mainly on terminology, and Developmental Pillars of Increased Autonomy for Aircraft. So these are guidance for those who are thinking about the subject and know that at some point standards will need to be developed. So these will be essentially resource guides to help them along. There is one more on the way. We're looking forward to it being published soon, Regulatory Barriers for Aviation Autonomy. And that is a look at some of the existing operational regulations, in particular Part 91, going line by line through the whole rule set and looking at if autonomy were to be implemented, what rules would have to be reviewed, potentially changed. So that will be an interesting something to read when it comes out. Next slide, please. Those who are in the industry are looking at this as a global industry, particularly the manufacturers on the aircraft side. So they want to encourage, wherever possible, harmonization between jurisdictions and authorities. So on the aircraft certification side, we already have, for those that are those eVTOLs that also fly on a wing, Part 23 for FAA and EASA CS23, that's what's being used as a certification basis. Use of industry consensus standards for means of compliance, common terminology. There I'll reference back to the technical report that has terminology in it that's very helpful to share. Alignment on aircraft categories. We have very traditional categories, airplanes, rotorcraft, etc. These aircraft fall somewhere in between, and there's a debate about what the best term is for that and potential category. So you've probably heard of powered lift. That creates a lot of complexities. It's a very active discussion at the moment. Ability to certify at the aircraft level. So for FAA, for instance, you can certify an aircraft and the engine and propulsion system underneath that without having to have separate type certificates for each. And with the integration of systems with these aircraft, especially with distributed propulsion, we're going to see that more often than not, where the propellers and the propulsion systems are unique to that particular aircraft. Process for accepting new technology and innovation. This is really important. It's a big challenge to get acceptance of any new technology or someplace where the current rule set doesn't speak to it. And the process is something that there is concern about from the industry side about how long that will take. So that's something that is worth thinking about. And then on the operations side, mutual recognition of eVTOL pilot in command and operator certificates. So if we can get the aircraft certified, we also need to make sure that we have something similar for the operators, and so they don't have to have completely different qualifications everywhere they would fly. Although it's understood that different jurisdictions are going to have different rule sets to some degree. Qualification of personnel on new technology. F-46, for instance, deals with personnel, and they're trying to establish common guidance for what personnel would, what kind of metrics there would need to be for the training and testing of personnel, for instance, to do maintenance or repair for new technology. Accommodation for highly automated operations in airspace and at landing facilities. So there's a very active ASTM process on vertiports that talks about highly automated operations. This is another one where it will be important that there be some agreement as to how that should work. So the real message there is that with this activity, and I think it was said before in ASTM, it's both encouraged, and we're happy to see the amount of participation from groups globally, both from the industry and from the authorities. And then lastly, cross-border transit agreements. Hopefully, if we do a good job on the certification of the aircraft and the operations, we'll be able to cross borders, because that certainly will be important for the economy. Next slide, please. And with that, thank you. Look forward to the question and answer period.
네, 발표를 해주신 탐 거너스님께 큰
Please give him a big round of applause.
네, 이번 주제가 eVTOL 그리고 Certification이라는 이제 용어가
So I heard terms eVTOL and certification. So I mentioned eVTOL earlier. So Tom Connerson explained the procedures for certification, I guess.
전문적인 용어 그리고
These terms are industry jargon, so maybe some of you might find it a bit difficult. So if I explain, I think all the relevant people in the industry are familiar with it, but for those who are not familiar with it, so this certification means that it's a mean to prove this aircraft is safe. Its safety is proven. But how we are going to validate That is the certification process. So next up,
세 번째 세션의 마지막 순서죠.
this is the last program of session 3. We are going to have a panel discussion with this morning's presenters. To moderate this panel is Chun Seung-mo, Director of UAM Technical Center of KIAST, and we also like to invite Nam Gung-pyeon and Park Han-jun to the podium. And the 4 speakers, presenters will join us virtually. Also, the Philip Conner, chairman of the ASTM Technical Committee F38, will join us virtually as well. So let me hand over the podium to the moderator. Good morning, everyone.
So I will be moderating the Q&A session for session 3 on certification and industry standards. Nice to meet you all. Before we start, so the session 3 is a very significant and meaningful event explaining the certification and industry standards at home and abroad. Well, as our MC has just mentioned, not many public accurately understand the certification process. Well, as many have emphasized, safety is utmost issue in AAM industry, and in Korea, MOLIT is in charge of the AAM and UAM, and they are making a significant effort to develop and establish related laws. And the KIAST is also supporting the MOLIT's effort, along with other certifications and related agencies. And many companies in the private sector are collaborating with the government institute as well. So as I said, session 3 is about certification and industry standards, and we have we have invited speakers in charge of these standards, and one of those experts is ASTM. And as for myself, I have also involved in this with the cooperation with the ASTM. As you know, ASTM is an internationally recognized standards organization, as Korea was revising Part 23. It is developing. It is an organization that is involved in developing MOC processes and regulations. So to introduce my colleagues over here on the stage, there's Mr. Park Han-jun from KIAST, and also from the KIAST I have Mr. Nam Gung-pyeong, and I also have our online speakers who have joined us for this session, Mr. Ame Gandu from Enra Technologies, Mr. Jonathan Daniels, Mr. Rex, and also Mr. Philip Knoll. And we have a lot of pre-collected questions for this Q&A session. And after asking these pre-collected questions, I will take up questions from the audience. Well, this is an online and an offline conference, so there are a lot of people joining us for this event. We have a lot of speakers for session 3, so I have prepared a lot. I'd like to ask this question to our first speaker, Mr. Nam Gung-pyeong from KIAST. Please be at ease.
So the expectation and interest is very high, and we have some questions for you. The first one,
농업용
So it seems that the unmanned aircraft system certification is essential for the real commercialization of civil UAS, such as cargo delivery and passenger transportation beyond the currently used photography and agricultural uses.
진행하고 계신다고 말씀하셨는데
So in today's presentation, you said that your organization is conducting a pilot certification as part of your research project. So unlike the conventional aircrafts, new technologies such as ground control systems and C2 communication between ground control and, systems and aircrafts are required. It is necessary to have the technology to confirm the safety of this new technology. So how is the KIAST as authorized aviation certification organization preparing for it? That's a very good question.
이제 우리 기술원에서 이
At our organization,
UAS에 대한 인증
UAA certification
체계와
system
인증 기술 기준을
and
담당하는데
standards
PM으로서
are being developed, and I am a project manager, and I've been thinking a lot about it and working on it a lot.
제가 가장 고민하는 부분은
So your question
혀를 찔러서 질문해 주셨어요.
is just about what I think mostly. To answer your question,
저희 그 기술원에서는 일단은 지금 현재 진행되고 있는 정부 과제를
the government research we are conducting
무인화하는 개조 작업을
lay a foundation to convert the manned aircraft into an unmanned vehicle, and we obtain core technologies for the certification here, and we have identified 4 core technologies for that. As I said earlier, ground control system C2 link
공중에서의 그 디텍트 앤 어바이드 시스템
and detect and avoid system,
이런 나가서 전기 추진까지
and even electric propulsion.
2030년대에 우리가 안전하게 비행할 수 있는
So these technologies are to ensure safe flight in 2023. But how to certify it is not just the work done by us. We invited top-notch industry experts, like around 40 of them.
계통별로 전문가 그룹을
We have
주기적으로
a regular meeting with them every 2 to 3 months, and we have categorized them into different systems and category.
국내적 측면에서뿐만이 아니고 우리가 놓칠 수 있는 부분을
And there must be something we might not be able to cover if we work alone in Korea.
해주셨는데 저희 기관이 계통별 그 전문가께서
We have experts by system,
무인 항공기의 이비토 기준을 만드는 그런 재정위원회거든요.
and we have a committee
하고 계십니다. 그래서
for with experts involved in the F-84 committee.
최신형으로 공유.
So these people work with international organization or committees,
그룹이 있습니다.
and there's another group run by FAA. There is Asia Pacific UAS Standardization Examining Committee.
이런 위원회도 멤버로 참석을 해서
So our experts are member of this
우리의 것으로 만드는 기술 기준을
efforts to develop Korea-specific standards. So this is my question for you. Thank you.
추가적인 질문인데
And there's another question.
우리나라 어떤 산업의 여건 때문에 질문하는 겁니다.
So this is about related to the Korean industrial landscape.
산업계가 영세합니다.
So the drone industry is still weak here in Korea.
그래서 무인항공기 시스템을 인증 위한
So certification of unmanned aircraft system is of course important.
절차가 부족하다고 많이 이야기를
And we're still lacking the related procedures and standards and institutions.
그걸 위한 인증이 가능해 보이는 것 같아요.
But based on your research, we will be able to certify these too.
그리고 우리나라 무인항공기 시스템
So what kind of technologies and regulation systems do you think are needed for commercialization of UAS in the future?
두 가지 측면인데
So we have to look at it from 2 perspectives. As for the institutional improvement, I think we need to improve or enhance our regulations or acts.
이러한 그 정부의 시범 인증 과제를
The government's pilot certification programs
저는 이제 그
is an opportunity. As a person involved in these projects,
현재까지 이제 무인화 개조해서 진행되고 있는 어떠한 그 아웃풋
the output we have obtained by converting the manned craft into an unmanned craft, we have been able to come up with a draft.
인증 기술 기준이 되겠죠.
These will lay the foundation for the future standards.
투자를 계획하고 있는데
Of course, the industry is planning a lot of investment in it too. But how we are going to design the aircraft, how they can get the certification to address these concerns of the industry,
조만간에 나오게 될 이러한
I think we'll be able to provide it in the future. So this draft will be submitted to the government so the government can provide an interim standard to further activate, drive the industry.
또 나아가서
And furthermore,
아까 그 유럽의 이제 그 인증 체계를 잠시 소개를 드리면
I briefly introduced the certification procedure of Europe. They analyze risk from the perspective of operators. So they are focused on the areas where certification is needed. For example,
사람이 거주하지 않는 지역에서
if
산악지역에서 비행한다거나
the aircraft flies over a mountainous area where people don't live,
카테고리를 분류해서 안전성
they also provide categorization for risk assessment.
적용하고 있는 그 이제 소라라는 프로그램하고 전문
We also utilize this SORA here in Korea. Maybe we can use this for drones or other expanded applications
도움이 될 것 같아서 저는 이
when they develop their aircrafts.
통계에 좀 건의를
So I'd like to make a suggestion to MOLIT
건의를 드리고 싶어요.
to adopt a similar structure here in Korea. Thank you.
우리나라의 법 체계가
Our
하신 것처럼
laws
중량
and regulation
분류되기 때문에 어떤 그
is based on the categorization by weight. So the risk factors are not considered enough.
그런 것들을 조금 전체적으로 무인 항공기 또는 항공기를 통합해서
So UAS and the drones should be combined all together to come up with the standardization and for
인증을 적용하고 안 하고
certification.
필요할 것 같습니다.
I think that's a way to step forward. Maybe due to time constraint, maybe I'd like to ask questions to a different presenter.
Mr. Park Han-jun from KIAST, you have talked about the AFSEC equipment.
오늘 UAM이니까 UAM 관점에서 먼저 질문드리겠습니다. 전통적인 항공기 서비스
So my first question is, in traditional aircraft services, as experienced at airports, aviation security is being emphasized in terms of passenger and navigation safety. Also, UAM is expected to emphasize security as a means of air transportation based on urban regions. Given the characteristics of UAM may require new security policies and technologies that may differ from traditional aviation security. Can you please tell us about the future policies and core technologies of UAM security that you expect? So the UAM project is being conducted at our institute. So regarding UAM, it is important to consider what kind of security system should be applied for UAM operations and services, and we are making those kind of efforts. The most important thing that we should consider is that we need to come up with a AFSEC system that ensures the safety of all people, including passengers. At the moment, considering the current level of AFSEC equipment technology, we need to also take into consideration the expected number of passengers for UAM. We believe that at the moment we still need some. We have still much room for development to adopt new technologies. For example, there's face recognition to detect any abnormal behaviors of passengers
보안 검색에 적용하는 건데요.
to detect any kind of criminal activities in advance. But we are making our efforts in a gradual basis. So at the initial stage, we are reviewing the possibility of adopting the current FSEC security process and system. And with the development of the related technology, when we move into the mature stage, we will be able to adopt more advanced FSEC technologies, for example, the face recognition, more advanced face recognition. And we can also combine those technologies, and we can also provide one-stop security screening system that can detect both cargo and passengers in the future. So we believe it will take about 10 years from the initial stage for us to move from initial stage to move into the mature stage. We will do our utmost effort to expedite the process. Thank you so much for your insightful comment. So we have well, I'm also listening to the interpretation. There are very expert technical lingos that's being considered as well. So there's FSEC technology. You are involved in detecting and screening process to detect any kind of harmful goods or any kind of illegal or criminal activities that can happen.
그래서 UM 시대에 대비하면 저희도 사실은 아마
So to make better preparation for the UAM era, cybersecurity should be ensured. That is one of the important factors as well. So far, aviation security has been focused on ensuring physical security, such as detecting dangerous goods and explosive, but you talked about expanding the scope of your work into cybersecurity. So can you share with us your plans? So since last year, we have conducted basic studies and research and for the cybersecurity as well. But our project hasn't been much involved in the cybersecurity. But I'd like to share a little bit of our plan. So we have started to recognize the importance of cybersecurity by looking at international cases. So in overseas countries, they recognize the possibility of hijacking of fuselage. So we have identified technologies to identify those kind of harmful situations. And we also developed the validation process for that kind of system. And for all those IT and cyber technologies, we believe there's a need to develop related systems to be put in place. And we have planned to carry out those research on cybersecurity this year. So we have ASTM with us for this session. When we're doing the certification for the part 23, our government has considered overseas cases for including the means of compliance and FSEC equipment. So standards developed by industrial standard organizations used in Korea and standards developed by ASTM, who attended today's meeting, adopted by Korea as well. So we are conducting certification for 8 different EVSEG equipment, and we are also utilizing locally developed test kits to do that. And we are also using test kits that are to do to carry out this task. And our test kit is in compliance with these guidelines, and there are 2 standards for our test kit. First is resolution, and second is transparency. And for X-ray screeners, they are designed to identify and screen the goods via the imaging. So the resolution and transparency are the 2 important factors for us.
소속돼 있는 보안항해 인증실에서는 우리나라의
And lastly, the KIAST is an authorized aviation certification organization in Korea that certifies aircraft materials, parts, aviation security equipment, and navigation safety facilities. So you are working at the Security Navigation Certification Office of KIAST, which is performing certification or navigation safety facilities. Can you briefly introduce your office? Yes, I am working at this Security Navigation Certification Office. So we have equipment. There is a MOLIT notification on the security navigation facilities. So these equipments can be used at the airport or airport operators or other related operators. So we are validating whether they are following the guidelines and regulations. At the moment, we are also doing research on the target location revision project.
네, 우리나라에서 개발하고 있는 항행 안전 시설에 대해서
So the navigation systems developed in Korea is now being certified by your organization, so that's very grateful. So I'd like to raise my questions to the presenters who are joining us from outside Korea.
여러 가지 온라인 하신 내용하고 여러 가지 질문이 있는데요.
We have received many questions, but I'd like to check the time first, so we can best utilize the time we have. So the first question will be directed to Amit Ganju from Enma Technologies.
첫 번째 질문입니다.
So here goes the question. As you have explained, for commercial services of private UAS, such as cargo delivery and public purposes, BVLOS is necessary. And of course, it is expected that the UTM traffic management of UAS, such as collision avoidance and danger security area geofence, is essential.
말씀하신 것처럼 ASTM 인터내셔널은 UTM과 관련된 활동을
As you said, ASTM is actively carrying out UTM-related activities and seems to be making efforts to develop standards.
앞서 그 스위스 같은 사례에서
So you pointed out a case from Switzerland.
하고 있는 것 같은데요. 혹시 상용 서비스로 UTM이 활용이 있는 사례를 추가적으로 말씀해 주실 수 있나요?
Can you tell us about the current status of the UTM commercial services that you are aware of?
So that's actually a great question. I just want to make sure I understood the question correctly. If the question is where all around the globe are commercial services being offered, if that's the question, it's right now, I always talk about it in 3 phases: innovation, experimentation, operationalization. So most of the Europe and Western world, it's moving from experimentation innovation to experiment. They're somewhere in between experimentation and operationalization. So Switzerland was the first example of where the published ASTM standard F3411 was actually deployed in an operational scenario. However, outside of that, in the experimentation phase, the ASTM standards have been used at multiple places. They have been used in Switzerland, they have been used in UK, they have been used in US for the NASA campaigns and the FAA campaigns. And currently, as we speak, so we have two published standards right now for the UTM space. One is for remote identification and the other one is the Uss Interoperability standard. So both of them have been experimented with, and remote ID one has been operationalized. The other one hasn't. But now as you move towards the UAM one, the UTM standard is being uplifted, and that is what we are calling a draft standard. So that's not necessarily a published standard. So that's the draft version of the next one, which is being used for the NASA Advanced Air Mobility National Campaign, and it's being exercised there. So per se, it's not a commercial deployment, it's more of an experimentation deployment, if that makes sense. Hopefully I understood the question correctly.
예, 아닙니다.
I think you got it right. Thank you for your answer. And I have additional question.
아시다시피
As you know,
항공기에서는 그 교통관리 시스템이 항공기를 인식하기 위해서 항공기에서는
UTM,
ADS-B
I'm sorry, ATM uses ASDM, and UAM uses remote ID.
UAM의 트래픽 매니지먼트를 위해서 특별한 장비가 탑재한.
So, do we need any special equipment for traffic management for UTM? Or is there any device for identifying by UAM traffic management system? When do you think this will be available? That's the additional question we have.
I'm going to try and answer what I understood the question to be. So there are two distinct aspects. There's an aspect of remote identification or electronic conspicuity. That's one aspect. And then from UTM or airspace management point of view, you have strategic deconfliction, tracking, and monitoring services. Those are related, but they are two separate services. So remote identification service is a separate service which just allows you to ID a drone and pull the information in. It's not necessarily for DAA or for tracking and monitoring. It's just for IDing an aircraft. So that's the remote ID. So for that, we have the standard 3411. Then we have a standard for strategic conflict detection, and which is the Uss Interoperability standard. So that is for, as part of that, you have pre-flight deconfliction, and then you have services such as conformance monitoring, where once you have declared your intent and you have created these virtual on-demand highways in the sky, making sure you stay in that highway, virtual highway in the sky, and monitoring your conformance. And if you go in out of that conformance, how do I notify the alert? Who do I notify? How do I notify? And if there's a need for dynamically reconfiguring of the airspace by creating a geofence around it, that can be done too. The system also, the standard also allows you to create a constraint on demand. And this is in line with what's being done in US and the European regulation, the ED 269, which lets you define a geozone. It lets you, the standard actually lets you, authorities, authorized users, to inject a constraint, a dynamic constraint, airspace constraint into a region, and there may be different rule sets associated with it, whether it's completely a no-fly zone or it requires further coordination for allowing flights in that area.
네, 좋은 답변 감사합니다.
Thank you for your answer.
반대 관계로 그 부연 질문을
I have additional question to clarify your answer.
앞서 말씀드린 거는 기존의
So actually what I wanted to say is that ASD was used for identification in the old aircrafts. And for drones, we are using remote ID or remote identification. Do you think we need additional equipment for UAS eVTOLs?
Okay, I understand. I think you mean ADS-B. I think that's what you're trying to say, ADSB. So ADSB transponder is the legacy. Aviation has been using it for long term. So, but if you plan to use that, or if you're talking about UAM aircraft, yes, you could potentially, if the number of aircraft flying is relatively low, you could potentially use ADSB. And early on, a lot of the UAM aircraft are going to be flying under VFR rules or IFR rules, and they will be optionally piloted. So they may have transponders on board. But as you move to scaled operations at scale, not these limited operations, you will need other forms of identification, because ADSB, for example, in US, FAA has already declared that ADSB is not going to be used as a form of identification for small UAS, right? So it's not practical. There are security concerns with ADSB and potential congestion of the frequency as well. So those are the concerns. So it depends on which geography, which part of the world you are in. There are different opinions, and it's a highly contentious topic where different people have different opinions. But in terms of equipage, as we move to the new form of aviation, we see network-based identification becoming a norm as a common means as we move towards BV loss operation. So when you rely on network-based identification, you don't necessarily need to have additional transponders on board. Now, you can pull in that information directly from the eVTOL aircraft going into the UTM network for identification in line with the standard, or you could put a module on there which communicates, or you can pull that information from the GCS into the USS network. So there are different mechanisms how you can pull in that information over the network into the system. So it's not a black and white answer. It depends on the deployment model, where it's getting deployed. But you can do without hardware, you can do with hardware. Both options are available.
네, 감사합니다. 마지막 질문입니다.
Thank you very much. I think this is the last question for you.
새로운 시스템에 들어오면 새로운 용어.
So when there is a new system or technology, we often coin new terms. And it is difficult, even for me, to understand these terms. There was a term PSU, I think that was explained near the end of your presentation. UAM traffic service provider. I'm not sure if I understand it or remember it correctly. UAM eVTOL is now in early days, and of course, in the earlier days, there will be onboard pilot. And there will not be many services available, only limited numbers.
아까 UML2라고
You said UML2 earlier. When do you think this is available?
So in terms of the acronyms, I apologize. So it's like a death by 1,000 cuts. You have so many acronyms, we keep on coming up in the aviation world. But PSU is provider of services for UAM. So it's just another name for UTM, but for design for the eVTOL world, the advanced air mobility. And in terms of the capability, when do we see UML2 happening? So you'll see experimentation. So if you look at specifically the NASA national campaign, the AAM national campaign, that's already looking at working towards the UML2 level capabilities. So we are part of the national campaign, and I know WISC is part of the national campaign on the flight side. So X4, they're different. And again, I apologize, I'm using acronyms again, but that's how researchers typically like to call different events. But the UML2 is happening, and it's being looked at in these research projects, whether that's simulation exercises, creating digital twins, or actual live flights happening. Does that answer your question?
이 부연 질문을 드리면 실제
I ask you one more question. When do you think we will need PSU? I'm asking you this because there are many related companies in Korea. They might want to understand when they really come to enter the industry with their services.
That's actually $1 million question. If I had a finite date and like a fixed date, I would give you that this date is exactly when this is going to be used. It's going to depend on the geography, on the regulatory framework, because the technical standards are there, but a regulatory framework for each jurisdiction is going to dictate when this service gets mandated and if that gets mandated. And there will be different scenarios, like are you operating in controlled airspace versus uncontrolled airspace? And PSU, there's a lot of touch points for PSUs. So at the end of the day, all these vertiports and the UAM have to be interoperable. So I wish I could give you like a black and white answer, hey, it exactly needs to happen by January 2023. I can tell you, like, for example, the European regulation says a use-based service is mandated by January 2023. So there's a regulatory requirement that puts a date in place. So everyone has to comply with some basic use-based services by January 2023. No such regulation has come into place for a PSU or a UAM traffic management yet, because it's in that, remember I talked about innovation, experimentation, operationalization. So it hasn't quite transitioned to operationalization. It's still in the innovation experimentation phase. But I envision it taking the same path that UTM services have taken globally, where they're now beginning to transition into operationalization. I expect the same to happen for the UAM. If you're asking me for, if I had to just throw out a date out there, I'm probably going to say a couple of years from now, you'll see limited deployments of PSU-like capability. I'll say PSU-like because PSU is also one of those loosely used terms, because there are a lot of services. At the end of the day, these services have to add to the safety of the airspace and the safety of the vertiport operation and others. And how do you handle approach departures? So I think over the next 18, 24 months, you'll see some limited scale deployments happening operationally.
네, 감사합니다.
Thank you very much for your answer. Let's move on to the next presenter.
버티포트 관련해서 조나단하고
So I'd like to ask questions to Mr. Jonathan Daniels and 5 Alpha about Verdeports. As you know, Verdeport is a core infrastructure for UAM services, and it is a fairly complex system. Unfortunately, there are no international agreements or government regulations about Verdeports yet. To our great delight, you have mentioned that FAA standards will be developed by 2024 about vertiports, and the advisory circular will be prepared in the future. Will the aviation authorities in the United States certify and approve vertiports in a similar way to aircrafts?
그리고 두 번째 질문입니다.
And my second question is,
형태, 안전 설계를 안전 설계
many stakeholders are curious about the safety requirements for vertiport designs. They also believe that the stable operation of vertiports is also very important to ensure their UAM flight safety. Can you please share us your views on the development of the standards from the perspective of the operation and essential facilities and their current status?
So, Rex, if it's okay, I'll take question number one.
네.
Question number two for you. Hi. So the easy answer on question number one, and thank you, that was a very well thought out question about the FAA certification, really comes down to one of the fundamental differences between how facilities are certified in the United States versus elsewhere. And it really comes down to one of two things. Either a facility is a public use facility or it is a privately owned facility. And that is the only two. And the FAA has majority of their oversight and rigor on public use, meaning it is open to any users of airspace who want to and can meet the qualifications to land there. Whereas private use allows you, the vertiport operator, facility operator, to only allow permissioned air traffic so that people cannot land and use your facility without your permission. They're mostly privately funded and don't receive public funding. And that is the big difference. So to answer the question, yes, they will, but if they're private vertiports, the FAA really doesn't certify them in the same way they do a public use. So if you build it and you meet minimum local building requirements, you've met the regulatory requirement, the FAA really doesn't weigh in. the way they do for the public use. So that was the easy question. And now I'm going to pass question number 2 to Rex.
Okay, thank you, Jonathan. I appreciate that. So that I answer it appropriately, could you please repeat question 2?
네. 버티포트의 형태와 안전 설계의 관점의 기준뿐만 아니라 운영 관점의 기준도 마련될 예정인가에 대한 질문입니다.
You plan to provide regulations for the stable operation of vertiports.
So in dividing regulations,
네, 기준을 여러 가지로
one of the key challenges we run into here in the United States is that the criteria is not truly a regulation. So we have regulations, but when you look at how heliports are currently developed, they're developed under what's referred to as an advisory circular. And an advisory circular, as John pointed out, for private use facilities is not mandatory. It is recommendation only. Other countries, when you look at the civil aviation authorities for the UK, you look at Canada and other civil aviation authorities, they actually have regulations that they have to meet. Here in the United States, we have several different parts that we fly under. So we have Part 121, which is air carriers, so United, American, Delta. Those aircraft are required to land and take off from airports that are certified. The only certification that the FAA gives out in the United States is under Part 139. 139 stipulates the airport must meet certain criteria, and that must be inspected annually. In the United States, heliports are not inspected annually. Heliports are rarely inspected ever. When you look at the total numbers that are involved, we have over 6,000 heliports in the United States. Out of that, only 58 are listed as public use. 99% are private use, which to include all the hospitals that have heliports in the United States. So as John pointed out, we have public and we have private. Those are the only two categories the United States currently has. A lot of the states, and this is one of the challenges we run into in the US, is we have the federal standards, then we have the state standards, then we have the local city and municipality standards. So when we get into the local municipality and the state standards, we have so many different ways of doing business that it's hard to really produce a good business case. When you look at some place like Canada, the Transportation Organization of Canada is the ultimate authority. There's one authority. We don't have that here in the United States. Other countries have it easier, I think, in that space than probably the United States. But when we look at the different certified areas that we fly under, 121 is the top, Part 135 is the next below that, and then Part 91. Part 135 is commercial operations, and there is no certification. The regulation for 135, 135.229 stipulates that landing areas will be adequate. Very subjective. So there's no standard, there's no certification, and there's no regulation, not like Part 121 with 139. What we will do in the future is yet to be determined. A lot of states have adopted commercial as a third category. Whether we adopt that as a federal category is yet to be determined. I hope I've answered your question. That's quite a bit.
네, 감사합니다.
Thank you so much for your answer and comments. And due to the time constraint, I'd like to move on to Mr. Tom Goranson.
아시다시피 많은 EV
As you know, many eVTOL manufacturers
서티피케이션 베이시스라고 합니다. 마련할 때 파트 23을
are using Part 23 when they prepare for the certification basis for type certification with aviation authorities.
이유가 무엇이라고 생각하십니까?
What do you think make many eVTOL manufacturers go for Part 23?
Simple answer is that Part 23, like CS23 in Europe, is a performance-based regulation, which allows for an easier path toward certification with new technology, because the regulatory language is generic. It's not specific to a technology. So there's a certain ease in using that. The other piece of that is that when the Part 23 was revised, the standards, the means of compliance, were taken out of the rule and given to industry to help develop. Therefore, we have industry consensus standards for which that guidance can be used as means of compliance to meet the regulatory requirements. So that works very well for aircraft that are not traditional. That doesn't mean that for eVTOL is the whole equation, because there are areas that still need to be covered. For instance, the propulsion system or a vertical lift system in an eVTOL, for which there are other parts of the regulations that would apply. So, for instance, with electric propulsion, Part 33. If it was propeller, it's Part 35. If it's the vertical aspects, those are rotorcraft regulations, Part 27. So, and those are not performance-based. And actually, that's where some of the most difficult discussions are right now. So, if it's possible for an applicant to use Part 23 as a certification basis, then that works best because it's performance-based.
네, 감사합니다.
Thank you very much. So when Part 23 was revised,
원리를 보면
when you look at the principles
인증에 대한
used,
제한 없이 많이 수용할 수 있도록 적용한 원리입니다. 그럼으로 인해서
so
산업표준단체의
I think
규격 개발이 상당히
the
중요합니다.
standardization is very important for many eVTOL manufacturers.
eVTOL 항공기를 개발하는 신생기업들이 많이
There are many startups here in Korea entering the eVTOL development business.
인증 경험이 전무해서 인증에
But they are not much experienced in certification. They are having difficulties.
이런 혁신적인 파트 2사의 개정본의 원리를 적용하더라도
Even we apply this new modified amended Part 23,
이하사 스페셜 컨디션인 SCV2를 조금 더 우호적으로 생각하는
they still believe EASA special condition SC VTOL is more preferable. So what do you think about it?
That's a trick question. So it's good that there are options for an applicant who is considering certification for their eVTOL. And so right now there's a choice to use either what SE VTOL in Europe or what FAA is offering. There are advantages to use one or the other. So that's something that an individual applicant would need to decide what works best for them. They are different philosophies. EASA is basically creating a new category of aircraft, which they're calling VTOL, which puts certain constraints on what the aircraft is going to be and how it will be operated, and the requirements to do so. Because they're trying to create something, one rule for everything, and there is so much variety still in eVTOL designs and their use cases, there are potential issues there that should be looked at. Type certification of an aircraft is not easy. There's no best place to go to save time or effort. It's a very difficult task because it's so complex and there's such a high level of safety expectation. So we want to encourage those who are considering developing these products to get involved, particularly with the standards groups. ASTM is a great example of where we have very regular discussion with the authorities, both FAA and EASA, and it's a great learning environment. So I would encourage, I think we all would encourage that those who are going down that path take advantage of that participation and the platform where they can learn more.
네, 좋은 답변.
Thank you for the answer. As you said, aircrafts with similar uses require the same level of safety and rigor internationally, but the approach to eVTOL aircraft certification is largely divided into the US Part 23-based and European SC VTOL-based certification basis.
계속적으로 추구해야 될 것 같습니다. 그래서 오늘
So we have still a long way to go, reach a consensus, and I think that's what makes this occasion more meaningful. I think we should wrap up with this panel discussion. I'm sorry, with this pre-selected questions. Let me open the floor for questions. Please raise your hand. There is one person.
마이크 좀 전달해 주시겠습니까?
Mic runners, where are you?
혹시 그 질문하실 때 소속하고
Please tell us your name and affiliation, and also pinpoint the person you'd like to ask the question to. I am Kwon Tae-hwan, researcher from KIAST.
Of F-38. We all know that there are many standard organizations such as ASTM, RTCA, and ISO, and American NC as well. Can you tell me what makes ASTM differentiate from other organizations from aircraft certification perspectives? I mean, aircraft here includes UAS and UAM. Thank you.
Your turn, Phil.
I'll take that question. So what makes us stand out from the other organizations? I'm not going to say that we are any better or any worse than any other standard organization, but each standard organization has their strengths and ASTM has a long history in emerging technology aircraft, starting out with light sport aircraft, which was adopted. Their standards were adopted globally. They were first established started establishing over 20 years ago. And from there, we've added general aviation aircraft and UAS aircraft. And one of the key things that I'd like to say about the standard communities is not that we're in competition with each other, but we don't want to duplicate efforts. So we want to complement the work that is being done in other organizations, and they want to complement our work. So ASTM has a very strong strong legacy in unmanned systems. And a lot of the unmanned systems that we work on in F-38 are the low risk category aircraft. In F-48, they've been doing general aviation aircraft, and they've moved very well into eVTOL aircraft, UAM aircraft, and advanced air mobility aircraft, leveraging the work that they've done in general aviation aircraft. We're also working very closely with RTCA so we don't duplicate effort. And one of the key areas that we've worked on with RTCA is detect and avoid technologies. RTCA is looking at the higher risk categories for detect and avoid, and ASTM is working on the lower risk categories, so we get the full spectrum of completed standard development by working together with RTCA. So I hope I answered that question and didn't go around in circles too much, but I just want to say it's not a competition. There's a lot of work to be done in standards development, especially in emerging technologies such as UAS and advanced air mobility aircraft.
네, 혹시 더 추가적인 질문이
Any questions? Okay, there's one more person. Mike, please.
네, 국민대학교 윤영현 교수입니다.
I am Professor Yu Young from Kookmin University. I'd like to ask the question to Dr. Nam Kung-pyeon. So according to your presentation material, you mentioned the Aviation Safety Act of Korea. You said the categorization of the current law is not sufficient to support UAS. And I think that your proposition of the new categorization and the type certification is very positive. But I think the current categorization of the current act is not correct. Aircraft. And there's another categorization for above 600 kilogram aircrafts and like very light aircrafts.
사람이 안 타는 것은 드론인 것처럼 이렇게 했다는.
And it sounds like light aircrafts without onboard pilot sounds like a drone. Ultra-light vehicle is the term used here. But I'm actually the head of the International Standard Organization, and ICAO and ASTM. This term is not used here. So I'd like to suggest an effort to define correct terms for the industry, the current categorization. Well, if we need weight as a criteria, we need to introduce it into the system. We also need to categorize it based on the type of the aircraft too. So type certification will be improved with the enhanced categorization. That's my opinion. Thank you for pointing that out. Actually, I really relate to your opinion. The Korean version of the categorization, well, we have the Korean version, but we actually have the English translation provided by the government. But I really agree because I felt the same. Maybe we can improve the system we have for categorization with terminology. Maybe we can actually make a proposition to the MOLIT and the government. So I will do that in the future. Thank you.
사실 저희가 준비된 시간을 지금 30분을 넘어서.
Actually, this panel discussion has overrun by 30 minutes.
발표해 주시고요. 그다음에.
So I think it's all thanks to your active participation from the speakers and the audience.
오늘 그 토론회를 진행하는 자장 입장에서는
As the moderator, of this panel discussion. I think I should have paid more attention to the time.
참여해 주셔서 감사합니다.
Thank you for joining us. Those who are joining us abroad, especially the ASTM experts,
합쳐서
related organizations, KIAST and MOLIT will have a discussion on a different occasion. We will work more closely with ASTM International. As Nam Kung-pyong said, we have expert committee composed of top-notch experts of Korea. If you can join us in this effort, that would be much appreciated. Now, the focus is more on the aircraft itself, maybe, but we can think about, include, and expand into the infrastructure, security checks. That will help us further develop the certification. And certification will allow us to develop the industry itself further. And the standards should be harmonized internationally as well, so we can achieve a balanced growth with the industry here in Korea as well. I hope you enjoy your lunch, and this is all for the panel discussion. Thank you very much for the participation. I'd like to thank the moderator and the panelists, and also those who joined us remotely. It has been a quite long discussion, but it was very meaningful as well. We could identify what we need to do in the future. So that's all for session 3. It's time to begin session 4, which is the last program of today. So why don't you give us the introduction? Yes, this is the final program we have today. So in this afternoon, we are going to listen to different companies' UAM plans and their progress. So after the KUAM roadmap was announced, many companies are interested in it, and also they make efforts to make their own plans. So let's take a look at how UAM companies in Korea are doing, what are their plans, what are their future directions as well. So let me introduce the first presenter. The cargo drone system development status and plan will be presented by Kim Jae-kyung of LIG Next One. Please give him a big round of applause.
네, 안녕하십니까?
Hello everyone. My name is Kim Jae-kyung from LIG Next One. Today, I am delighted to be invited at the International AAM technical meeting. At this meeting, I will touch upon cargo drone system development status and plan. So last year, at the end of last year, we joined the UAM Team Korea. So we plan to actively involved in the UAM Team Korea projects at the company level. So from now on, I'd like to briefly introduce you about our cargo drone system development status and plans. So this is how I will proceed with my presentation. I'll start with the overview, development plan, and I'll also touch upon schedule, followed by utilization plans.
본 과제에 대한 개요입니다.
And this is a brief overview about our project. So there are many words, nicknames that calls the VTOL cargo drones with a payload of 200 kilograms. So the title is called the development of technology for VTOL cargo drones with a payload of 200 kilogram class based on high hydrogen fuel cell capable of automated flight and remote control flight. So we need three requirements: 200 kilograms and hydrogen fuel cells and automatic flight, automatic operation. So at the moment, we are cooperating with Gwangju to. This is a project carried out in collaboration of Gwangju to develop a cargo drone center.
간단한 이제 운용 개념도입니다.
So this is a brief diagram. So I've said this is an overview of how our cargo drone with a payload of 200 kilogram will be operated. So for private use cargo drones, the private cargo drones will be really beneficial to deliver products to remote areas such as islands. So I have numbered it. If you can, we can start from the transportation planning. As I've said, using drones, we develop a plan to deliver goods in a safe way to an island that is less than 200 kilograms. And second, we load cargoes and we start the automatic, and then afterwards we start the mission, and we move on to the number 3. We do the vertical takeoff. So it is remotely, it will be remotely controlled. So supported by the GCS. It is mission-based. So according to the mission schedule, using the onboard equipment, we can monitor and check the safety of the operation of the flight. And so we do the automatic mission flight and move on to number 5. We do the vertical landing and we unload cargo from the drone. After completing unloading cargo, we do the vertical takeoff and then we make the return flight in an automatic way, and then the drone comes back to the base. And we recover all the related the drones and GCS equipment. So I have just explained that we do the takeoff and do the mission flight, and then unload the cargo, and then fly back to the base. This is how it will become carried out. Let's take a look at the development goals. We are pushing forward our project in line with various government policies. So I have mentioned to you that we are developing a cargo drone that can carry weight to the maximum of 200 kilograms. So this project was first we started planning for this. The government started to planning for this project back in 2021, and then we started to. We were commissioned with this project So we plan to develop this cargo drone with a payload of 200 kilogram. Based on hydrogen fuel cell capable of automatic flight and remote flight control. And the payload is more than 200 kilogram, flight time is more than an hour, max speed is more than 100 kilometer per hour. And it is, as for the power, it's hydrogen fuel cell plus battery. Although it is based on hydrogen fuel cell, plus battery, but at the existing battery that is used for automobiles lacks the capacity to be flown over. So there are room for improvement. These are related, the comparison of the domestic and foreign hydrogen fuel cell cargo drone development status. So let us first look at the domestic side. So as I've said, the payload is, at the moment, we are aiming for 200 kilograms, but most of the domestic payload is around this level, which is kind of on the lower end.
추후에도 좀 더 저희도 이제 개발 동향을 좀 파악하도록 하겠습니다.
And
그래서 현재 저희가 수행하고 있는
so
카고 드론은
the cargo drone project that we are operating by LIG, next one. These are our goals. The name of the
친숙한 제품명으로 아시겠는데요.
name of our model is called KCD 200. It is Korea cargo drone, and we attach 200 because it has a payload of 200 kilogram. When we develop the fuselage for this, this is a tentative name. When we finalize our model and finalize our development, we plan to give it a more fancier name. So when it does vertical takeoff and landing,
리프트 크루즈 형태입니다.
it will. So the flight type is lift cruise.
그다음에 운용 반경은 50km 이상.
The maximum radius is 50 kilometer. The max speed is 100 kilometer per hour, and the payload, I have already told you that it is 200 kilogram. And these are the quantitative goal performances. We have carried out analysis on quantitative terms. So our first goal is analysis result, verification of the analysis result, and our second goal is verification of the flight test and environmental test. So our first So starting from last year, the first stage will be 3 years until next year, and the following 2 years will be step 2. So ultimately, on year 4, which will be our final second last year, we will be able to finalize the development, and our goal is to deploy this cargo drone on year 5. So there are various kinds of advanced technologies that are applied to cargo drones. That is why we are collaborating closely with various kinds of stakeholders and organizations.
LIG 넥스원에서 수행을 하고 있습니다. 카고 드론 분야에
For cargo drone, there are different kind of components. The fuselage, the mission equipment, and the core. There are other core components. And to develop those core components, we are also working with related organizations. And we are also collaborating with Gwangju.
들어와 있습니다.
So you can see there is Gwangju Techno Park, because the Gwangju city is also participating in this project. And if you look at this project, the project is largely divided into 3 sections: air vehicle, GCS, and UAM, DMP center.
임무를 수행하도록 최적의 구동 계통과
So we are trying to build the optical view model with the best driving system, propulsion system, avionics system, with multi-data link and electronic system that can do the missions with the advanced mission equipment. And we also plan to attach LiDAR, radar, and various kinds of devices as well. And as for the GCS, we are currently developing ground control vehicle and ground control equipment. And as for the UAM DMP center, we will also build a ground control room, and we will also provide a place for testing, providing experience and education. And last year, we displayed this mock model at one of the fairs last year. We are at the preliminary design phase. So we are, as I've said, this is a lift cruise system with the main wings and the rear wings. On the rear, we will have the pusher propeller, and the entire length of the model will be around 10 meters. It will be the maximum. So the size is 10 by 10, and the maximum payload is 200 kilograms, and the mission radius is 50 kilometers, as I've said before. The ultimate performance goal is to make this model that can carry a payload of 200 kilograms, and the maximum speed is over 100 kilometers per hour. Maximum flight time is 1 hour. As for the power, it will be powered by hydrogen fuel cell plus battery. This is a cargo drone that can be applicable in the private for the people. But this model can also be carry out military functions as well. And for that, we plan to build a security system that to enable this model to carry out military functions. And we are calculating the link budget to have the mission radius of 50 kilometers. And we are also making the hybrid system for the power because it uses the hydrogen fuel cell and battery. So before cargo drone, we will So we have various experiences in developing avionics systems in collaboration with the military R&D center. So one of our goals also include avionics, mission equipment, and flight control fields. And the flight will be able to automatically detect any kind of potential accident or potential extreme terrains. And the next is ground control, GCS vehicle, and HUMS, and charging station, HMD, and secure. And as I've said, it is based on hydrogen fuel cell plus battery. For the batteries, the battery will be charged before or after it carries the missions. And lastly, it's about environment and laying the foundation for environmental. The last one is the environmental factors such as temperature and wind speed and rains. And we are carrying out various kinds of tests to make sure that we have the right design. And one of our goal is to our goal is very ambitious, and we'd like to propose this by the Aerospace Review Committee for the standard proposal, and we also plan to have it approved by plan to have approved FDIS. So let us look at the evaluation items and methods. So basically, we will take a look at all the CD data. So one of the qualitative goal for the step 2 is having the flight test verification. Whereas one of our goals for the step 1 is a critical design data verification. So these are our qualitative goals for step 1 and step 2. So as I've said, we have started this project last year. It will run for 5 years. So during step 1, which is the last year, we had carried out the development management and evaluation, and then we have completed KOM and SRR last year, and this year we plan to finish PDR, and next year CDR and step 1 assessment will be made, and in year 4 TRR, and we will carry out the ground test and environmental test. And ultimately, with the support from the Gwangju city government, we will carry out flight tests on year 5. So these are some of the expected effects from the KCD 200 project. So LIG, next one, places a high priority on ESG management. So under our corporate ESG principles, we believe that we can contribute more to the society through this project. So through commercialization of the cargo drones, we can improve air quality and contribute to the hydrogen economy by using decarbonized hydrogen fuel cell. And also, we can create a new drone logistics industry by creating a drone-based cargo distribution network which transcends land and sea-based cargo transportation. And we also expect to increase and enhance accessibility to lands or mountainous areas. So in the future, using these cargo drones, we believe that we can improve the quality of life of the residents in these isolated or remote areas. And also, we expect to use these cargo drones for relief activities as well as military supply support activities. And let me move on to the conclusion. Through this cargo drone development project, we plan to create the UAM original technology in Korea, and we believe that we will create commercial and military markets for cargo drone systems. And we believe that we can facilitate hydrogen economy growth, which is one of the strongest drive by the Korean government. And we also believe that we can build a strong UAM infrastructure. Thank you so much for listening.
Please give him a big round of applause. So cargo drones as well as passenger carrying UAM is a very interesting category. So passenger carrying urban mobility is something that will come later, but these cargo drones will arrive sooner, I believe. And I expect LIG will be advanced the arrival through their efforts. Let me introduce the next presenter. Multi-role integrated UAM platform development will be presented by Cha Hong-jun from KAI, or Korea Aerospace Industries. Please give him a big round of applause. Good afternoon, everyone. I am Cha Hong-jun, Senior Manager-in-Chief of KAI. I am in charge of technology development and UAM TF. So UAM is one of the hottest industries, and we are now developing multi-role integrated UAM aircraft with payload of 600 kilograms. So let's start with the contents. First, I'd like to talk about the UAM market trend, vehicle features, roadmap, and also KAI UAM. And then I will finish up with the future plan. First, the UAM market trend. So this is from Vertical Flight Society, and this is very recent numbers from this month. So there are many companies developing eVTOL aircrafts, except for electric rotorcrafts and hoverbikes. There are around like 600. So earlier last year they said like around 300. Now we have 400. In the aviation, especially civil aviation, there are limited numbers of aircrafts. Then we have seen a sudden increase in the number of eVTOL, and the biggest contributor is that the propulsion system, which used to be the biggest barrier for most companies, is now become electrified with advancement in the batteries and the motors. Now many startups have entered this business. Joby and Lilium, they have come up with tangible results with financing. So that's what makes others to join the industry. So let's move on to the status by type and region. There are development going on in 48 countries, mostly in Europe and in the US. I think that's because aviation industry is much more advanced in these regions, and startup ecosystem is more advanced in these regions as well. So mostly Germany and the US are leading the effort. So let's take a look at by type. In the earlier days, EHang and Volocopter were leading, but now they have been replaced by vector thrust lift cruise with multi-copters. And now around 44% of the vector thrust. Now, let me introduce some major players. I think most of you are interested in eVTOL and UAM, and these names must be very familiar to you. The data is from SM Consulting, a Korean consulting company. So they take a look at the industry based on the number of the aircrafts to see whether commercial level services is really available. They also look at the their technology readiness, certification process, and production readiness, funding received, and the team that led the company. So they selected 24 companies out of like around 400. So they have received around 8,000 orders. So and in the amount is like $560 million. It's a huge market. So among them, 15 countries declared the introduction of the commercial services in 2025. But the thing is, the aviation industry is quite unique, especially in the civil aviation. Commercial and Boeing and Airbus takes up around like 95% of the market. So it still remains to see whether the market will be dominated by a small number of companies or maybe become a fragmented industry. So it will be very interesting to watch. Next, let's take a look at the characteristics of the UAM aircrafts. There are many characteristics that we want to take a look. Economic sense, performance, noise. But first, I'd like to talk about the safety. To have a successful UAM industry, reliability should come first. On your right, this is A301, A350, and there's another one, KC-100. These two aircrafts were developed by two different companies, but they have something in common. That's the 10 to, the catastrophe failure rate. That means that when the flight is destroyed or death occurs, it's 10 to the minus 9.
UAM은 현재 유럽 항공안전청에서 작년에 발표한
ESA announced special conditions. They also require 10 to the minus 9 for catastrophic failure rate.
카테고리 enhanced란 부분입니다. 그래서
There is a category enhanced.
비행하는 기체는 10의 마이너스 9승.
So if the flight goes over a densely populated area, the catastrophic failure rate should be 10 to the minus 9. This is a very strict rule that is often applied to the commercial manned aircrafts, like large planes.
쉽게 시장에 진입했던 업체들이 과연 이 기준을 만족할 수
So
있느냐에 따라서 기술적으로
whether the companies that are already in the industry will be able to meet this condition, that's a question. And of course, we need a certification process to validate it. There will be a type certificate or production certificate. Well, this may sound that we are bragging. Until 2013, we developed KC-100, and we are the only entity with type certificate and production certificate. And we also entered a bilateral aviation safety agreement with the US, even expanding into the aircraft.
그러면 저희 회사에서 그 UAM이 차지하는 위치와 의미에 대해서
Then what is the meaning of UAM's position at our company? I think if you are interested in our company, you may already know.
대형 국책 사업,
KUH and large national projects
파트너로 참여하는 민수 사업들을 주력으로 하고 있습니다.
and civil projects are our key business areas.
분야에서
We have 5 business areas that we want to further develop our capabilities. First is the future air mobility, UAM, electric aircrafts.
전 세계적으로 크게 일어나고 있는 4차 산업혁명.
The fourth industrial revolution is happening across the globe,
UAM 사업을
and that trend has been reflected into our business strategy to choose AAM as one of the key future business areas.
테크놀로지 컨버전스 부분입니다.
Next, technology convergence. As you know,
수직 이착륙하고
UAM should be able to take off or land vertically. They also will be able to provide unmanned autonomous flight.
결합체라고 할 수 있습니다.
So this is a combination of fixed wing and rotary wing aircrafts. We have small helicopter aircrafts
차를 나르는 전투기까지
and even a fighter jet that can fly at Maha
저희가 30년
at a very fast speed.
약 2,000명 이상의 항공 전문 엔지니어
We have around 2,000 professional engineers. We also have a huge database.
저희 회사는
We are leveraging this
을 새로 만드는
to develop
집중할 계획을
a UAM, and we will focus our capabilities on it.
기체 하나는
These two aircrafts, the one is manned and the other one is unmanned.
아덱스 때 공개한 모델인데요.
This is the models we unveiled at the ADEX earlier.
항공기에서는 실험기에 X를 붙여줍니다. 저희가
We usually add
항공기가
letter X for experimental
эк스페리먼트를
vehicle.
붙여주는데요. 저희는 이 기체에 에코-프렌들리 일렉트릭 익스페리먼트에서 E-스퀘어 X라는 이름을
E-square X is the name of this vehicle because this is an abbreviation of eco-friendly electric experiment.
X 모델을 만들면서 고려했던 사항들을 간단하게
This is what we considered when we designed this model. We reflect the customer needs. We also analyzed the market trends in the process. UAM required in this area should have at least 5 seats and should be able to fly at least 100 kilometers. For the military purposes,
무인 항울기 payload 600kg급의
unmanned vehicle, unmanned with a payload of 600 kilograms, is needed. To meet these needs, we considered 2 factors. So we set our operational goal, also requirements. I don't have it here, but we have more than 10 concept sketches. We invited experts to select 4 designs eventually. We also considered the size of the rotors, performance of the aircraft, controllability,
E-스퀘어 X
to finalize 2 types of E-square X, which were released at RX.
저희 E-스퀘어 X의
E-square X
특징이라고 한다면
is unique in commonality.
발행하는 데 있어서는 3천억 이상의 비용이
To develop a model, you need at least like 30 billion won. And of course, for the infrastructure for that model, you will need more investment. So it's really burdensome for a company to develop 2 different aircrafts. So we wanted to identify the commonality, the powertrain, avionics.
결정을 하였습니다. 그렇게 해서 양산 기간을
So that allowed us to shorten the mass production period and also save cost.
전방에 4개의 틸트 로터를 가지고
It has 4 tilt rotors on the front,
방향으로 도는
and we also has co-rotating rotors on the rear side.
약간 걸링이라 하는데요. 갈매기처럼 돼 있습니다.
So it has a wing that looks like a gull wing.
안정성이 뛰어난 스타일입니다.
It provides high stability. We think UAM is not like a fighter jet that requires maneuverability.
승객들의 시야를 확보하기 위해서
And
선택되었습니다.
gull wing was elected for a wider view of the passengers.
와이테일의 장점이 중량
We also went for a wild tail because it's light,
날개에서 날아오는 후리의 영향도 적게
and it will be less affected by the wind in the rear side. Of course, there is some side effect in controllability, but the trade-off is something that's worthwhile.
보시는 것처럼 붐테일을 사용했는데
We also used boom tail
카고를 싣고 내릴 수 있게 채택하였습니다.
for easy loading and unloading.
고민을 좀 했던 부분인데요. 그 랜딩 기어 담당자 입장에서
For the landing gear,
스키드 타입을 이제 선호했었습니다.
the person in charge preferred the
근데 실제 저희가
ski
고려했던
type.
부분은
But what actually we considered was that
자유롭게 움직일 수 있어야
it should be able to operate
착륙을 했을 때
in an autonomous way.
불가능하죠. 그렇기 때문에 저희가
And ski type
고려해서
is not proper when we consider the taxing. So we went for a different tricycle landing gear for easy landing and parking.
간단한 제온입니다.
These are the specifications.
탈 수 있고요.
So it will be able to carry 5 passengers, payload 600 kilometers for cargo loading.
프리리미너리 리ኳ이먼트에
So these,
MTW가 2톤으로 되어 있는데요.
as you can see here, in preliminary requires
사이징
MTOW is
되는 약 2.5톤의
1,000 kilograms, but in the end we ended up with 2,000 kilograms. I think the requirements will be updated in the future. The maximum speed will be 250 kilometers and range is 100 kilometers. The range is shorter compared to other aircrafts because of the battery, so it's somewhat limited. To complement that,
시행했고요.
we started a project on a hybrid system.
연구를 착수할 예정.
We are also start another project on the propulsion system.
예. 저희는 그 고객의 요구에 따라서 맞춤형 기체를
We can provide customized air vehicles to meet different customer needs.
인증을 받은 기체들의
Vehicles that are produced overseas and certified in Korea, certified in foreign countries, they cannot be easily certified in Korea.
기본적인 데이터뿐만 아니라
Not just basic data, but also
시험에 관한 모든 자료를 통해서
all the materials and data for certification
기체를 만들 수 있을 수
will be utilized to develop
민간 버전에 군용 버전으로 네 가지를
civil or military aircrafts that meets the customer needs. When it is used for military purposes, we can use it for command, utility air assault, freight transport, and medical evacuation. If you want it bulletproof, we're going to add it.
민간과 다르게
Unlike the civil application, if you want to add a capability to drop the cargo in the air, well, we can add that too. So we call it MADVAC.
위험한 전장 지역을
If you need to fly it over a war zone,
만들 생각입니다.
then we will be able to make it unmanned to fly it there.
그리고 다음은 저희가 아덱스 때
Next is the
운용 개념에 대한 영상을
video about our demo, which was released at ADEX. So please watch it together.
예, 잘 보셨는지요?
I hope you enjoyed the video. Lastly,
생각하고 있는 UAM 향후 계획에 대해서
let me show you our future plan.
1차적인 목표는
Our first goal
2028년까지
is by 2028
다목적 UAM에 대해서 상용화를 하는 게
to commercialize a multi-role UAM aircraft, and we are going to gradually increase the payload and increase the number of passengers to 10.
핵심 기술을 익히려고 하는데요.
And we will, of course, develop the necessary technologies by making investment in lightweight materials and
시스템에 대해서 저희가 과제를 하나
many others. We also conducted another research on the hybrid. We already started another project on hydrogen propulsion system. So,
친환경이나 비용 측면에서 가장 중요한 내용.
cost effectiveness and eco-friendliness is very important here, and we are also looking at the thermoplastic materials.
기술 대회자를 마치고 29년에는
In 2029, we are going to expand our business into the electrified aircrafts. In this area, electrified UAM can be combined all together. And if we combine all the information or data we have in these areas, we will achieve quite good competitiveness in this sector. That's all for future UAM plan. Thank you very much for your attention. Let's give him a big hand for the amazing presentation. So, KF-21, the fighter was launched last year. I think KAI is leading the industry. I'm wondering how their UAM will be utilized in the military and how their UAM aircrafts will provide amazing performance. Let's meet another presenter virtually.
Allow me to introduce our next speaker, Mr. Hon Long Chu from Volocopter. The title of his presentation is Volocopter Brings UAM to APAC. Please welcome him with a big hand.
Hello. Good afternoon. My name is Hon Long Chu. I'm the head of APAC for Volocopter. I have the honor of presenting to you Volocopter today at the International AAM Technical Meeting in Korea. What you see in front is a real picture of our Volocity air taxi with real passengers on the side there. Welcome to the future. Let me give a brief introduction of Volocopter. So we are a German-based UAM manufacturer and operator. Our mission is to make sustainable urban air mobility for everyone come true. On the right here, you see our 2X aircraft flying over the heart of Singapore in the Marina Bay in October of 2019. This marked our entry into the Asia-Pacific market. I'll quickly go over the technology that's behind our eVTOL vision. We have 5 products that you see on this page here that I will briefly go over and then more in detail on the following slides. On the top, we have the Volocity and the VoloConnect, are 2 air taxis designed to serve the urban use case and the regional use case. In the lower middle, we have the VoloDrone, which is built on the Volocity design, which allows for heavy cargo logistics of up to 200 kilograms to be used in a urban or in mountain settings. On the lower left, we also have the VoloPort, and on the lower right, we have the VoloIQ. These 2 make up the physical and the digital infrastructure that's necessary to complete our UAM ecosystem. Let me go into the details of each. The Volocity is our flagship product, the one that you saw on the front page. This is the urban air taxi. As you can see from its design, it is a multi-copter design with 18 motors and rotors at the top. It is fully electric, and it has the capacity to carry up to 2 passengers when flying autonomously. We planned to begin operations with a pilot on board with just 1 passenger in the very beginning. Now, the key about the 18 propeller design is that it allows us to achieve the highest safety in aviation, 10 to the minus 9. This means that the aircraft will have less than 1 catastrophic failure in 1 billion flight hours. This is the same standard that commercial jetliners that carry 300, 400 people are certified to. We will have a flight range of about 35 kilometers, which is more than enough to carry passengers between densely packed urban environments at a cruise speed of up to 90 kilometers per hour. On the next slide, we have the Volo drone, which, as briefly mentioned, is our heavy lift drone that is based on the design of the Volocity. Here you see the Volo drone flying publicly for the very first time in Hamburg as part of ITS World Congress in October of 2021. It has a lifting capacity of, again, up to 200 kilograms, fully electric, the same 18 propeller design, up to 40 kilometer range, and most importantly, we also anticipate to certify the aircraft up to a 10 to the minus 9 standards, which we believe is necessary in order for the aircraft to fly over heavily populated areas like cities. Moving on to a bit in the future, we have the Volo Connect, which we also announced last year with a miniature flying prototype. The Volo Connect will be extending the reach of our aircrafts up to 100 kilometers and increasing the capacity that we can sit on board up to 4 seats when flying autonomously. It is still fully electric. It has a lift and cruise design, which allows us to operate the 6 motors to lift the aircraft during the takeoff and landing phase, but then the twin propulsive fans will move the aircraft forward in the cruise phase. This allows us to fly at a much faster speed, up to 180 kilometers per hour, and most importantly, at the same time, still being able to achieve the 10 to the minus 9 safety level that we believe our aircraft needs to operate safely. Now, I'll quickly go over the digital background, right, the backbone, the Volo IQ. On the next slide here, you will see, right, what the Volo IQ covers. We really envision it to be the operating system for the UAM industry, the software part of it. Right. This is what's going to allow for a scalable support system for efficient UAM operations. On the right, you see the first screenshots, right, of Volo IQ to be used internally to allow us to live monitor our aircrafts while they're in flight, right, for safety and efficiency purposes. On the left, you see the different portions that Volo IQ covers. We cover, of course, the whole aspects of the customer journey. So this is the app that you will use when you book a ride on our air taxi. But it will also cover air and ground operations, flight analytics. It will help us manage our batteries, maintain logistics, right, and also help with in-flight connectivity. We really see the Volo IQ as the software backbone that helps us put together all of the aircraft. On the other side, on the ground, in terms of what's physically present, we have the Verdeport. Now, in Q4 last year, we published the first functional, ready-to-use Verdeport handbook in a press release on our website. We welcome requests from partners, right? And we look forward to opportunities to deploying the Verdeport all across the world, and of course, very specifically in South Korea. It has a fully functional design that accommodates both the Volocity and the Volo Connect. It's modular, right? That's allow it to be built first, right, on a small plot of land or on top of most rooftop buildings. And over time, as the operation scales, the port can also be expanded for increased capacity. true to our values, it has a very small ecological footprint, right? We want to be sustainable throughout our whole value chain. And of course, it takes into considerations the ongoing regulatory development for vertiports all around the world. Right, so we welcome the opportunity to work with partners all over the world and also in Korea to develop and deploy VoloPorts everywhere. So moving on, we would like to outline what we can do with the products that I just introduced, right, to bring UAM to the Asia Pacific region. This is our eVTOL vision. And we start with Singapore. Right? When we flew for the very first time in Asia Pacific, it was at the very heart of Singapore, over the marina, right, which is, of course, the very heart of the central business district in Singapore. Less than a year later, we announced our commitment to launch our air taxi services in Singapore in December of 2020. And very much hot off the press, I'm very excited to announce that at the Singapore Air Show this week, we have published our roadmap for launching in Singapore. This is a detailed handbook that goes into the details of what we mean by launching UAM services in this city-state. And we, of course, outline the different benefits that it brings, the societal, environmental, economical, and political benefits. As the headline, we expect to generate 4.18 billion Singapore dollars in cumulative economic benefit and hire up to 1,300 jobs in Singapore by 2030 with the launch of UAM. We detail out the potential routes and use cases, really providing a grounded way of how we expand our operations. The initial launch that we see will be touristic routes, similar to the route that we took during the flight trial in the Marina Bay in 2019. We will also add touristic routes in the Sentosa Island. After our launch of touristic routes, we then expect to launch cross-border routes, flying from Singapore to neighboring islands and countries like Indonesia and Malaysia. We see also UAM as an enabler to help the Singapore government achieve its Green Plan 2030 and act as an engine for economic growth, right, in the post-pandemic world. So, and last but not least, we see the UAM service as the next milestone that will allow Singapore to retain its position as the Sentosa Island. After our launch of touristic routes, we then expect to launch cross-border routes, flying from Singapore to neighboring islands and countries like Indonesia and Malaysia. We see also UAM as an enabler to help the Singapore government achieve its Green Plan 2030 and act as an engine for economic growth, right, in the post-pandemic world. So, and last but not least, we see the UAM service as the next milestone that will allow Singapore to retain its position as one of the most innovative cities in the world. If we move on to China, we have now a picture here of Chengdu, which is where our joint venture with Geely is located. And on this slide here, you see the formation of the joint venture between Volocopter and Geely, right, to bring electric air taxis and heavy lift cargo drones to China's cities. This formation of the joint venture was accompanied with a pre-order of 150 vehicles of VoloCity, VoloDrone, and VoloConnect, which will help to serve the initial demand, the very initial demand that we expect to come from the joint venture in China. Once we have announced the joint venture, we've also displayed our aircraft actually at multiple locations at, of course, the Shanghai Auto Show, one of the largest auto shows in the world, and certainly in China. And we've also displayed our presence at the Zhuhai Air Show in October of last year. We believe that these two events and announcements, right, will pave the way for us to build out the outstanding partnership that we have with Geely. If I may move on then to Japan. Here we have two significant pieces in progress. The first is that we have worked with Japan Airlines, right, and signed an agreement to develop and launch air mobility services in Japan. More importantly, this includes a pre-order of 100 aircrafts by Japan Airlines, right, to, again, reserve the initial aircraft necessary for operations in Japan. We've also announced that we have joined the Osaka Roundtable, which, as part of the engagement, also committed ourselves to flying during the Osaka 2025 Expo. We believe that all of these pieces together, especially with Japan Airlines, will help us build the strategic partnerships that's necessary to launch UAM services in Japan. Let me quickly also mention Malaysia. So in 2021, we've also announced a joint feasibility study that is ongoing with Malaysian airports, Skyports, right, and ourselves to study the feasibility for Verdeport deployment all over Malaysia, but starting with the Subang International Airport, which is the smaller airport closer to the center of KL, Kuala Lumpur, and is also happens to be the private jet hub of Malaysia. With our expertise in air taxi operations and air taxi design, as well as the joint expertise that Skyports has when it comes to Verdeport design, we believe that we can add value to Malaysian airports to help them understand how a Verdeport can add value to all of the airports that they have throughout Malaysia. Let me now move to Korea. I think we're very proud, as some of you know, to have flown twice in Korea. I will briefly show a video that many of you are probably there for, right, in terms of presence. The first is at Gimpo Airport, where our 2X aircraft flew. And you can just see here how stable and how smooth the flight actually is. A few days later, we also had the honor of flying in the Incheon airfield. And again, with this video, you're able to see the presence of our aircraft, right, and just how stable the aircraft was when it comes to maneuvering, right, as well as landing. Both of these aircrafts are manned, right, are crewed, right, so they have a pilot on board. And of course, we were able to obtain all of the necessary approvals and permissions necessary in order to fly at these two, at such proximity to two major international airports. You know, following the flight trial, we've also announced, right, our feasibility study with Kakao Mobility. When we look at the need for us to improve on the traffic conditions on the ground in Korea, we see Kakao Mobility as our key partner, right, to understand and then to market our service. The goals of the feasibility, as you see here, is really to try to identify the list of commercial routes, some of the operational capabilities, as well as the business models that are necessary for a UAM operator in South Korea. We expect, as announced previously, we expect for the findings to be released very soon, and we look forward to commercializing the service together by 2025. So let me close by saying, you know, when we looked at looking back, when we look at the flight trial that we did here in Singapore in 2019, we really saw that as the opening of our Asia Pacific office, but also our Asia Pacific market entry. We believe that the Korea flight trial that we did in November of 2021 also helps to serve as the market entry point for Volocopter in Korea. We have hired our first people on the ground in Korea, and we look to expand the team quickly. We are forming partnerships and consortiums to allow us to bring together all of the necessary expertise in order to launch the UAM service in Korea. And we expect to do so in alignment with the KUAM roadmap that MOLIT has published. So with that, I want to thank you for your attention and thank you again for giving me the opportunity to present Volocopter to you today.
네, 발표해 주신 헌렁
Thank you so much, Mr. Han Long-chung. Please give him a big round of applause. So it has been pre-recorded presentation. Thank you so much for sending us this insightful video. So he has shown us a couple of footages regarding. Did you actually saw these footages about the demonstration flights at Gimpo and Incheon Airport? Yes, I heard the news back then. Well, Volocopter's model was demonstrated here in Korea, so this would be very familiar to many of the audience. Well, I saw it with my hand, with my eyes, during one of the events in Germany last year. It was like, have you been on board? Well, it's a mock-up, but I had an opportunity to sit on this mock-up. But it didn't fly in the sky. But I hope to see the day will come when we can hop on these vehicles. Well, let me introduce the next speaker from overseas as well. And the next presentation will be by Edward Xu of EHang. The presentation will be about building the ecosystem for urban air mobility. So he will he'll be joining us remotely. So let's meet him.
Hello?
Hello, can you hear me?
Yes. Please go ahead.
Thank you. Hi, everyone. Good afternoon. My name is Edward Xu, the Chief Strategy Officer of EHang. So I'm very happy today to share with you our view on the urban air mobility. And so first of all, I would just like to start by going from the concept. So the next slide, please. Basically, UAM as a new concept has caught attention by various entities in recent years, including especially the government, companies, research institutes, and other organizations. The next slide, please. Yes. So here, let me just walk through a brief history of UAM development since 2016. EHang, as a leading UAM firm, has unveiled the world's first autonomous air vehicle, or AAV, in 2016, which was called EHang 1A4. This AAV is designed to carry one passenger to fly around 15 minutes, which is suitable for typical UAM scenarios. What's more important, it is fully autonomous, so that the passenger doesn't need to have any piloting skills at all. Later in that year, EHang built the world's first UAM command control center, which defined the operational model of urban air mobility through a point-to-point, fully autonomous and centralized platform. In 2019, IATA held a global aviation summit in Montreal with a panel especially for UAM, showing great interest and attention by the world's aviation regulators from the highest level. In the same year, EHang completed its global IPO through NASDAQ, making the world's first public UAM firm. Soon after that, EHang 216, a two-seater AAV made by EHang, completed its maiden flights in 3 Korean locations in 2020. In January of 2021, Civil Aviation Administration of China, or CAC, has officially accepted EHang 216 type certification application. Later in that year, we also witnessed the listings of more UAM firms in the world, including Joby, Lilium, and Archer. According to Morgan Stanley's latest research, the global UAM market is expected to grow into a $4 trillion market by 2040. So now we are standing here, the very beginning of a great UAM era. We feel proud that we are leading the curve to change the world. The next slide, please. With increasing enthusiasm by governments and investment institutions, we see the emergence of firms with various designs of aerial vehicles in recent years, including global aviation giants like Boeing and Airbus, as well as startup firms including EHang, Joby, Volocopter, etc. While many of these designs are still in early stages, it brings great innovative ideas to the whole industry. The next slide, please. So looking at the development of urban air mobility, we think it could be defined roughly in 3 levels. UAM version 1.0. The urban air mobility has been conducted by conventional helicopters within cities, such as New York in US and Rio in Brazil. With human pilots on board, there is a lack of a digital online platform to ensure high accuracy and safety. The next slide. For UAM version 2.0, it should be upgraded with both digital platform and the new version of aerial vehicles, which are lighter and more eco-friendly, with lower emission and noise levels. However, a human pilot is still on board in such version. Next slide. For UAM version 3.0, which is the current model developed by EHang, we emphasize the key features of full automation with computerized piloting, 5G online platform, point-to-point flight operation, and cluster management skills. From the perspective of safety, efficiency, and economic costs, we believe this should be the future of the industry. Next slide, please. So coming back to the topic, it is important to understand what UAM aims to achieve. It aims to change the world, change our urban life by changing mobility. Traffic problems and air quality issues are broadly complained by city dwellers nowadays. Can we make our urban life better, safer, and cleaner? Yes, we do. The new UAM model gives us a solution. Basically, it offers convenient and safe and fast urban transportation and 3-dimensional transportation through the air, eliminate traffic problems, and green energy with 0 emission. So in defining the right model of urban air mobility, we think it should possess the following characteristics. First, the 3D transportation to improve efficiency. 2, point-to-point routes with autonomous flights to ensure safety. 3, vertical takeoff and landing to improve convenience and flexibility. And 4th, electric power to eliminate carbon emissions. Next slide, please. Moreover, we need to build a whole ecosystem, including a centralized platform with distributed local command control centers to operate multiple AAVs in real time. The next slide, please. So basically, we define the key elements of UAM ecosystem as the following. 1, autonomous aerial vehicles, or AAVs. 2, command and control platform. And 3, regulatory bodies. And 4th, infrastructure. And 5th, ATM and UTM synchronization. So next, I'm going to elaborate further on each element. Next slide, please. For AAVs to be suitable for urban air mobility, it needs to be safe and reliable, autonomous and intelligent, can be controlled in clusters or groups, real-time network connected, and eco-friendly. The next slide. Not only do we need the small, limbo, short-range AAVs to travel within cities, but we also need the larger-size AAVs with the longer range to travel between city clusters, such as the Bay Areas. We believe the longer-range AAVs can be connected with the short-range AAVs seamlessly to complement our existing transportation systems. So as you can see, this is a picture of VT30, which is an eVTOL that are designed to connect with EHang 216, the short-range AAVs. The next slide, please. For future commercial operations, we emphasize the convenience, safety, and the speed of power charging. Especially, we highlight the Smart Battery Management System, or BMS, to ensure safe and efficient use of energy. Next slide, please. For autonomous flight control, we emphasize the use of point-to-point route planning with the help of AI technologies to ensure the high accuracy of the flight, including takeoff, cruising, and landing. Relative to human pilots, we believe AAVs with autopiloting functions can prove to be safer and more accurate. Next slide, please. For our centralized command control platform, the key functions are route setting and planning, AAV dispatching and monitoring, pre-warning, cluster management control, and contingency risk management. So here is a picture of EHang's command control platform built in Guangzhou in China. So through this platform, we are able to control thousands of AAVs simultaneously in real time. Next slide, please. From the government and the regulatory perspectives, it requires a compilation of laws and rules to foster the healthy development of UAM industry. Just like the invention of cars over 100 years ago, nobody had any sense of traffic laws at all. Since technology and innovations are always ahead of regulations, we expect the issuance of standards by relevant government bodies. It is great to see the new progress made by various government entities in recent years, including China, Korea, US, and Europe. We believe these progresses will lead to the prosperity of UAM industry in the next decades. The next slide, please. So specifically, I'd like to share with you the EHang's progress in airworthiness certification since the beginning of 2020. As you can see, we did many tests for manned tests, and after that, we are entering into the autonomous certification process. Especially, we want to highlight the certification of fully autonomous aerial vehicle is the world's first of its kind since the start of the aviation industry, which could set a new milestone for the world aviation industry in future. Next slide, please. Meanwhile, we have been also working closely with various regulatory bodies in the world to obtain flight permits, including US, Austria, Canada, Korea, and Japan, and Indonesia, etc. The next slide, please. So far, EHang's global footprints cover 10 countries and over 40 cities, thanks to the support and acceptance by local regulators and government bodies. The next slide, please. As we highlighted earlier, infrastructure constitutes a key element to UAM ecosystem. We envision the emergence of more accessible landing pads, charging centers, AAV terminals, and upgraded 5G and 6G network among the cities in the future to facilitate the proper operation of UAM services. The next slide, please. And finally, we highlight the importance of the synchronization of ATM and UTM, especially with a focus on low-altitude aerospace management. Similar to IATA's Astm certification, we believe the low-altitude aerospace below 300 meters need to be separated carefully for the use of AAVs in the future. While this level has minimum effect on existing aerospace for both civil and general aviation, UAM services require much higher frequencies and densities of AAV flights within the cities, which need to be managed in separations. This further supports our view that point-to-point autonomous flight operations are necessary to ensure the high accuracy and safety. The next slide, please. And finally, I'd like to share with you some use cases in real life by EHang's AAVs. First, this, as you can see, this is a passenger transportation. We did over 20,000 manned flight tests in all over the world, which proved to be highly reliable and safe. We made our maiden flight in 3 Korean locations on 20, which was well accepted by the local people. And next slide, please. And here is a picture of the emergency rescue scenario use case we made in Korea as well. So during the existing COVID-19 outbreak in China, we sent our EHang 216 AV for the rescue and also the transportation of medical supplies and patients as well. And also we have this EHang 216 firefighting version, which is designed for high-rise building firefighting, can be put into use for this firefighting emergency as well. And next slide, please. Right now, we see the very popular use of the aerial sightseeing because of this autonomous limbo flight. Passengers can enjoy the scenery from a different angle in the sky, which is highly popular in many Chinese cities nowadays. And the next slide, please. Especially, we launched a 100 route initiative in 2021 in China. We established AAV routes in China's Hong Kong, Macau, Canton, Greater Bay Area to test the operational model for UAM. So far, we have made good progress under the guidance by CAEC. And in the future, we look forward to sharing with you the results of our plan implementation. And finally, to conclude my presentation, I'd like to share with you a video of our AAV flights in recent years. We believe the UAM future now. Please play the video. Thank you. Okay, thank you.
네, 에드워드 슈님의 발표.
That was all for Edward Shu's presentation.
나스닥에도
So Yihang is already listed on NASDAQ.
영상에도 잠깐 나왔는데
네.
이항도 마찬가지.
As you have already seen, Yihang is quite a familiar name to us. In 2020, the first feasibility trial was conducted in Yeouido.
어저께 중국에서 발표를 했었을 때도 이제 지금
Yesterday, another presenter from China talked about Yihang's aircraft and its certification. I wish for the successful certification. So let me introduce the next presenter.
Our next speaker is Mr. Jung Min-chul of the Korea Airport Corporation, who will deliver his presentation on Verdeport site selection criteria. Please welcome him with a big hand.
안녕하십니까.
Hello everyone, my name is Jung Min-chul. I'm from the Korea Airport Corporation. I'm honored to be here with all of you at this technical meeting. So KAC is operating 14 airports across Korea, excluding Incheon Airport. So we have a headquarters for the navigating the routes for the aero vehicles. We are overseeing all those navigation routes for air vehicles, and we are also providing trainings for pilots, and we also operate various kinds of ground facilities as well. So we have abundant experience in operating and managing various kinds of airport-related facilities. So we believe that we have very much of strength to operate such kind of facilities for a new kind of vehicles, such as vertiports. So we are operating airports well. I'd like to explain how we select sites for airports or vertiports. So
산업에 있어서 가장 핵심 축입니다.
the vertiports is a core infrastructure of the UAM infrastructure. So it takes about 40%, according to the Munich University's research. They expect the vertiports will take up about 40% of the UAM infrastructure, while the Korean research expects about 20%. So, in a simple term, it would cost around 20,000 won over the total 100,000 won for vertiports. So, as you know, all the cities, many of the cities across the country are highly populated. Well, we have existing helipads on the rooftops in these densely populated regions, but it is difficult to utilize this existing heliport for new type of aerial vehicles. So, which is called UAM. So we believe that it will be challenging to build UAM vertiports in highly populated regions. There are many factors that need to be taken into consideration, such as accessibility, obstacles, land, public acceptance, and energy. And as you know, we also need to consider noise factors as well as charging facility, because we need to have super fast charging facilities. So where should we build these vertiports? Overseas, there are Joby, Aviations, or other leaders, UAM leaders, they are better positioned to build vertiports because they have large land compared to Korea. So compared to those kind of countries which have large land, Korea's situation is a little bit different. We face a lot more challenges to build vertiports because we are a small country with high density of the population. Well, so it is vertiport is not like bus. There are three different ways to build vertiports. First is to build vertiports in a closely related regions, such as as we would build bus or taxi stops. And second, we can build it in a more mid-sized regions. And third, we can build it in a more wide areas. As I've said, we need to take many factors into consideration before building vertiports, including land cost, high-rise buildings, public acceptance, traffic, and public transportation. Let's see the phases for vertiport site selection. The first phase is to determine determine the UAM demand in cities. Then we can identify the required number of UAMs in the city. And there will be some of the demands. Some of the passengers who used to use existing transportation modes would convert to UAM when it is popularized in the future. So there will be some passengers who would convert to use UAM.
서울 김포에서 잠실까지 약 한 5만 원에서 7만 원 정도의
So according to our research, people say that they will be willing to take UAM from Seoul to Jamsil for a cost of 50,000 won. About 5% of the people said so. So we need to calculate this. We did a calculation taking these kind of things into consideration with 5 to 7% of the conversion rate. So this is what we will do for the phase 1, and the next phase is phase 2. In phase 2, we need to select UAM service area, which is more a wide area.
서비스 에어리어 중에서 세 번째 단계는
And the next step would be phase 3. So in phase 3, we will select vertiport location within this UAM service areas. There will be economic, technical, and social factors that we need to take into consideration, and we need to weigh these different factors to build to select the most optimal site for vertiport. So I have the vertiports can be large, medium size, or small size. But building a large vertiport would be really challenging because it will require MRO services. It needs to be a hub. So it would be difficult for us to build such kind of verti hub in a large scale in the metropolitan region or at the center of the city. So we expect that we could build this large-scale verti hubs at the suburbs. So within the cities, we will be able to build more smaller-sized vertiports. So this is so we plan to utilize we plan to utilize the existing Gimpo airport to build a large-scale Verti hub. So you can watch the footage on next project, or you can also type in Verti hub or Verti hub in Seoul on YouTube. So this is what we will do in phase 1 to determine the demands for UAM in city. So this is the formula that we use to calculate conversion rate.
를 할 수 있겠습니다. 이거는 이제 지금 당장
So if we were to conduct a survey, we could drive the demand for UAM for the people at the time being, but it is better that we advance and further develop this kind of models to better forecast the future demand of for the UAM among the people. And let's move on to the step 2. So after determining the UAM demand, we need to select the site. So we need to locate this vertiport in a place with a high demand. So where would be the places with high demand for UAM? It would be the areas with high traffic demand or highly congested regions. So according to the Korea Transport, these are the heat map data based on the KTDB or the Korea Transport Database. So on the left-hand side, on the far left, we have Gimpo Airport and Incheon. And on the upper side, we have Uijeongbu. And on the southern side, we have Suwon, Dongtan, Hwasong, and Yongin. And these are some of the potential places for vertiports. So this is an example. Let's say that we need to build 10 UAM vertiports in Seoul. So using this heat map, we can locate the candidate site for vertiports, the UAM service area, excuse me. And moving on to the next phase, which is a step 3. In this stage, we can select the site for the potential sites. So time is one of the most important factor that we need to consider in this process. So in order to reduce time that is spent for traveling, we need to make sure that there is nothing that decrease traffic in the sky. So the people need to access vertiports within 10 minutes or so, which is about 4 kilometers radius. And as for the service area, we believe it should cover about 4 kilometers in radius. So in Gangnam, we can create a circle with a radius 4 kilometers for the service region, which covers COEX, GBC, Seoul Medical Center, Jamsil Stadium, and Tancheon Public Parking Lot. And using the criteria that we have, we can evaluate and select which would be best among these 5 candidate sites. So as I've said, we need to take into consideration economic factor, technical factor, and social factor in the process. As for the economic factor, we need to consider land cost, accessibility, and rental fee. As for the social factor, there's noise and visual effects and law and policy. As for the technical factors, the ease of construction and energy and safety. Some of the technical factors in phase 3 should be weighed based on criteria. So we need to, these kind of our potential site needs to meet all the requirements based on these three factors. So this is our plan. In this plan, there will be hub and ports. So based on conversion rate, by 2030 in Seoul, we believe 160 vehicles will fly over the sky in Seoul. So at night, we need to build a storage or maintenance facility for these vehicles when it doesnn fly the skies at night. To build that kind of facilities, we need about 300,000 square meters of area. And it will be difficult for us to build that kind of warehouse within Seoul metropolitan region. So it would be better for us to build those kind of warehouse facilities in the suburb. So we believe the best model would be hub and spoke model in the metropolitan region. And we believe at least one hub would be needed in small to medium-sized cities. And so it will fly at around 50 meters above the ground at the angle of 12 degrees. So there's a little bit of calculation going on when UAM, suppose that UAM is flying at an angle of 12 degrees, then within a radius of 100 meters, there shouldn't be any obstacles to ensure the smooth operation and flight of these vehicles. And as I've said, time factor is of utmost importance. That is why supercharging is needed. We believe that about 1 megawatt would be needed to charge one vehicle. And if suppose that we build this kind of vertiport on the rooftop, and if they kind of without expanding the capacity for electricity for that existing building, there might be blackouts in the nearby for that building or in the nearby region. So we need to think about the capacity of the electricity for that as well. And we also need to take into consideration of the law. As you can see, there are various kinds of laws that we need to take into consideration. And there's airside design. So for this, we need to make sure that we provide sufficient airspace to avoid collision in the sky. And to transfer from one vertiport to another vertiport, we need to ensure the fastest transportation and operation. And we also need to consider topology and scale. To build the most effective vertiports, we also need to take into consideration of the scalability of such facility. And there are many literatures, but unfortunately, there are not many criteria that we in the literature about this vertiport site selection.
선정을 할 때 이런 기준들을 고려를 해야 된다라고 지금 설명을 하고 있고요.
So these are some of the few examples which describes vertiport site selection criteria in a few literature.
정기적인
And according to the NASA's UAM Vision Concept Operations UAM maturity level, it features some kind of explanations, and it also says that it is important to consider the noise level when building the vertiports, and the site selection criteria are pretty similar to the criteria for existing airports, and FAA and ICAO do have these kind of criteria, and those in yellow are the common criteria. And these are some of the criteria provided by FAA. We also need to consider all these factors. And according to the Kogan report, we need to think about land cost, the airspace flexibility, noise migration, and scalability. So we need to think about all these kind of factors in these 3 stages. So
수요가 많은 지역 내에서의 세부 지역을 구성을 할 때는
when providing and building vertiports in areas with high demand, we can utilize open spaces such as public parking lot or park near CBD. And we can also receive support from the government with less restrictions for these open areas. And later, we might be able to build these kind of vertiports in across small rivers or in new places, or we can also we might be able to utilize existing gas stations. 20 years or 13 years into the future, we will be able to see various kinds of vertiports across the country. So I have already touched upon step 1, 2, 3, vertiport site selection process. And I have also mentioned some of the important factors that we need to take into consideration while selecting such sites. So the vertiports for the UAM, should we scale this UAM, and will these UAM vertiports be different from the existing airports? And we need to think all these factors and criteria. Thank you so much. Thank you so much, Mr. Jung Min-chul. Please give him a big round of applause. So KAC is actually involved in the UAM-related projects and activities. So if you please look, if you recall the last picture on the last slide, this is a blueprint for vertiport at Gimpo region. At Gimpo region, there's a mock-up image. If you have time, you can take a look at it. So I hope I can see this kind of vertiport in sooner than later.
And let me give you the last speaker of this session. Our journey to urban air mobility will be presented by SK Telecom's Lee Seok-gun, team leader. Please welcome him with a big round of applause.
네, 안녕하세요. SK텔레콤.
Good afternoon, everyone. I am Lee Seok-gun from SK Telecom. Thank you for inviting me to this honorable occasion.
오늘 제가 발표 드릴 내용은
My presentation
기술 내용과는 좀 거리가 있을 것
is a
같아요.
bit
좀 기술 내용뿐만 아니라 어떤 저희가
distant from the technical perspective. This is about how we view the business opportunity, what we are thinking about. So that's what I'm trying to hear. That's why I'm here to share with you. At SK Telecom, we are highly interested in social issues and ESG. So we have a vision of an ICT-based sustainable future, and we are trying to tackle the climate change by achieving net zero by 2050. So we are targeting. We have a target of emission reduction of 47.4% by 2030. We always talk about traffic congestion and green energy in terms of UAM. That's our interest. And we also trying to provide new experiences and services based on our technology. That's why we have become interested in this UAM opportunity.
SK텔레콤에서 추진해왔던 내용을 간략히
Let me introduce a brief history of SK Telecom's UAM business. Back in 2009, and of course before, we were interested in drones, but in 2019 we started our project on UAM, and in a timely manner, MOLIT established a future drone transportation office, and
기업만 바라보고 있는 것이 아니라
that made us realize that not just companies, private businesses, but also the government was looking at the industry. And back in 2020, we become initial member of UAM Team Korea.
절대로 혼자 할 수 없는
And everyone realized that this is not something that can be achieved by individuals working alone. So we work with others like Hanwha Systems, Korea Airports Corporation, and the Korea Transport Institute. Last year in November, we witnessed a demonstration project at Gimpo International Airport. By using UAM aircraft, we tested the communication capability of UAM aircraft. And with the leadership change, we also set up a dedicated organization and UAM task force under CEO. And in 2022, this year, we entered a partnership with Joby Aviation for strategy collaboration and to find future directions of the business. And to introduce the task force, the organization will be led by CEO. There is a UAM business team, and I am a member of it too. And under UAM task force, we cover business network, technology solution, corporate relations, and service development.
앞에서 말씀드린 SKT 얼라이언스
And SKT Alliance that we addressed earlier involves Hanwha Systems, KAC, and KOTI.
주요 활동 내역을 보자면은
And our activities together include smart mobility
실제로 탑승을 해볼
of Seoul City. So that was a demonstration project to actually take the flight. There was the demonstration project at Gimpo International Airport. We used a volocopter aircraft to connect it with a smartphone for communication with the ground control center. And we also provided different experiences with Hanwha and R&D projects from the government. There are 2 such projects, and 3 companies are working together to draft an intention for participation.
잠깐 언급드린 또 조비와의 파트너십인데요.
And to explain more about the partnership with Joby, this January we signed a strategic collaboration agreement in Marina, California.
그 조비의 역량을 더해서 그 국내에서
The Joby joined the existing consortium
같이 논의를 하고 있는
to
상황입니다.
discuss how to bring UAM service to Korea. As you understand, the company is very much ahead of the others in terms of the aircraft design. The maximum speed, altitude tests have been conducted, and the results were made available publicly.
그때가 이제 최고고도 테스트를 하던 상황이었습니다.
Back then, when we entered the agreement, the company was testing the high altitude.
저희가 생각하고 있는 어떤 필요한
So they were testing 7,000 feet flight operation. So that actually was more than we needed, and it was a great opportunity to witness their technology.
이제 저희가 바라보는 그 UAM 내에서
So let me talk about our views on UAM. What is our approach? What is the opportunity we have in mind?
정해진 것도 없고 다들 예측의 분야다
As for this,
생각이 다를 수 있는데요.
we have different ideas because there's nothing set yet.
입장에서 볼 때
As a service provider,
이런 어떤 부분이 있을 것이다. 다음에
we expect
어떤 고려사항이 있을
the
것이다.
things I'm going to address soon.
설명을 드리고자 합니다.
So that's what I'd like to share with you.
일단 서비스 관점에서 볼 때는
In terms of UAM business, we can think about 4 different parts.
중요도를 가지거나 같은 계위는 아닙니다.
They do not have the same priority, but
고객과 접점에서 그 UAM 탑승
as for the customer-facing side, there will be the service platform.
그다음에 저희가 또 기본적으로 통신 사업자다 보니까
Since we are a communications company, we cannot leave the network behind. And also the communication between vehicle, B2B communications, we are going to implement a different network for the service.
서비스를 직접 제공하는 어떤 서비스 운영, 오퍼레이션 쪽이 또 있습니다.
And operation, service operation is something to think about. And PSU for traffic management will be the last one. So let's go over one by one. Let's start with service platform.
서비스를 제공하는 컴포넌트 사이에 존재해서
So this platform exists between the UAM and the customer. Customer makes a reservation.
그 서비스를 제공하기 위해 동원된 비클, 버티포트,
Vehicle, Verdeport, PSU will be connected by the platform. For example, by selling the amount.
직접 원하는 장소에서 UAM을 탑승.
Customers will be able to ride their UAM aircraft whenever, wherever they want.
우버 엘리베이트도 이제
Uber Elevate is also dreaming of a similar model. Of course, now the business has been divested. The platform business can be activated
기체도 많아야 될 것이고
by a higher number of aircrafts for the service, and also operators vertiports. And of course, there should be demand from customers.
다량의 수요와 공급이 있을 때
Huge demand and supply should come together to support the platform and make it more valuable. Maybe in the midterm, we will be able to find more value in it.
직접 적절한 그 버티포트 경로 제시 또는
Platform will be able to propose adequate aircrafts or routes to.
두 번째는
Secondly, network.
UAM 또는 이제 항공
UAM or aviation air control network is requires higher QoS
이 네트워크
compared to the commercial service for the public.
네트워크를 사용할 것으로 예상되는 운항사 또는 기체가
Operators and aircrafts that are going to use this network
비용을 지불할 것으로
will
보이는데
pay
이 부분은 아직
pay the cost to the network operator, but that's it's not really unclear because
지불할 것인가 이런
who
부분도
will pay based on what standard and what kind of network will be laid out has not been decided yet. The pictures below
실증했던 내용인데요.
show the scenes of the demonstration at the Gimpo International Airport. So they are the people on the ground communicating with the UAM aircraft in the air.
아직까지는 사업화 이전이다 보니까
Since the commercial service is not available yet,
관제를 위한 안전을 위한 통신 쪽에 또 많이
communication for safety between ground control and the aircraft is very important, of course. But when you think about it from the service perspective,
비즈니스 고객들이 탑승할 가능성이
business customers are more likely to use this service.
20분, 30분 동안 핸드폰 사용을 할 수 없는 것은
And for them,
굉장히 크리티컬한 요소가 될 수도
if they cannot access the internet during their flight, this will become a huge barrier to the use. So that's why the aerial awareness network is the key infrastructure for UAM service. Thirdly, operation. Many reports released by consulting firms focuses on the UAM service area.
서비스를 제공하는 그 전면에 있는 서비스 운항사 쪽이
Of course, service provider operators will take the largest share of the market.
제공하기 위해서는
To provide the operation service of PSU, Verdeport, insurance, security, and other entities should work together and have a contractual relationships. And to ensure safety, the government should provide the license for this kind of business. As for the business model,
직접 컨택할지 또는 플랫폼을 거치지
the customer may contact the platform or the operator directly, and the platform will redeem the cost to the operator or the Verdeport. That's how it makes the profit. Lastly, PSU.
역할을 할 것으로
Routes management of the operational intention.
등으로부터 또 수익을 얻고
They will get profits from the operators and redeem the cost to the data providers.
하고 있는 역할을 대부분 국토교통부 또는
Now the roles that PSU can be played by is now being served by the MOLIT, the government.
드론 때부터 그런 얘기가 나오고 있고
There has been talk about it since we first started the business with drones.
비행 승인 그다음에 그 비행
Flight route settings, flight approvals.
민간에 이양할 것이라는 전망도
Not all of them cannot be decided by the MOLIT. Some of them should be contracted to the private sector. But there has been a discussion about how much of this can be reassigned to the private sector, because we need to think about the data flow.
사업성이 얼마나 될지도 아직 미지수고
And PSU profitability
좀 의문이 있는
is still questionable.
네, 다음은 저희가 이제 다음
Let's move on and let's think about what will be the next steps. We have a meeting with different people and they are all curious about our vision of UAM. We are not only providing network connectivity but also provide other services. So we have not defined our business scope yet, but our vision involves
엔드-투-엔드로 이 서비스를 프로바이딩 할 수 있는 주체가 되겠다.
the provision of the service as the service operator.
직접 소유를 하든지 또는
We can own the service or manage the service or have a contract with the service provider. Operation, PSU, network, and platform
서비스를 제공할 수 있어야 될 것입니다.
will be all integrated for the service provision. And of course, we have to closely work with the infrastructure provider.
어떤 식으로 파트너십을 맺고 어떤 식으로 확보할
What kind of partnership we are going to have, how we are going to proceed with it, will be clarified as the industry will attain clarity and as it moves forward.
통신사로서 고객들에게 또 서비스 제공하는
As a telco,
수 있는 부분이라 함은
maybe we can provide a differentiated service to the customers.
서비스를 고객들이 이용할 수 있게 진입을 시키기 위해서는 유도를 하기 위해
To drive users to try UAM service, maybe we can offer a benefit or
혜택이나 이런 것들을 활용해서 그 UAM 서비스
an initiative or incentive to attract customers.
이 UAM 탑승이 일회성에 그치지 않고
And to have repetitive customers, maybe we can think about a subscription business model.
현재 SK텔레콤이 T-우주라는
SK Telecom has a subscription platform called T-우주. It involves not just
제시를 하고 있는데
communications or data, but also others,
UAM 탑승이
like e-commerce. Maybe this will allow us to make UAM more accessible on a daily basis. And as for the user experience, we can also provide contents like OTT services to make it more customer-friendly.
UAM이 상용화되었을 때 저희가
When the commercialization of UAM is achieved, we can think about this kind of customer journey. Maybe a CEO from an overseas company visits Korea for business, and before he get on board the flight, he reserves a UAM from Incheon Airport to the hotel, so he go directly to the Verdeport, get on the UAM, and use the internet during the flight, and he can check in before the arrival. And in the city, he can also use UT taxi service for transportation, and this will shorten the trip to 20 minutes. And let's also think about a recurring customer. Let's think about there is an office worker using a subscription service, so he can use the service multiple times per month or per day. So he goes to Verdeport in Yongin using a scooter, then goes to Uljiro, then he also goes to his office using UT. To achieve this organically coordinated journey, we need a capability to integrate different elements. So here, a telco can play a role. This is our roadmap.
있을 것 같습니다.
You can look at it in two different categories: R&D project and partnership. Grand Challenge will be held tomorrow. There, you will be able to check all the requirements. And so we are also aiming to participate in this. And there are two R&D projects from the government. I hope that our alliance can have a successful outcome here. And we are now expanding our partnership network. And if we identify others to add value to this partnership, we are willing to expand it.
이상입니다. 발표
So that's all for my presentation. Thank you very much. Please give him a big round of applause for his presentation. So when you think about it, the speakers we have today are mostly from the aviation-related agency, but he is from a different industry. But SK Telecom entered a partnership with Jorby. They had an agreement, so that's what I saw from the press release.
네, 뭐 오늘 발표하신 것처럼 이제
As he said, I'm really looking forward to the wonderful collaboration and progress in the future. So we will invite the speakers today for the last Q&A session and the panel discussion. To moderate this session, we have Professor Park Jae-hong from Hansa University, who was also involved in the development of aircraft for the Korean Air. And for the speakers, please come up to the stage, and the online speakers will be also joining us on the screen virtually.
Mr. Kim Se-kyung of the LIG, next one. I'm afraid that Mr. Kim from LIG, next one, can't be here with us for the Q&A session for session 4. So I'd like to invite our moderator. Hello, my name is Park Jae-hong from the Hansa University. I'm going to moderate this session. So with me, there is Mr. Cha Hong-jung from the KAI and Mr. Jung Min-chul from KAC. And from online, we have with us Mr. Edward Shu from EHang. So we have already received pre-collected a series of questions. First, I'd like to ask some questions to Mr. Cha Hong-jung of KAI. In the process of, we had a lot of questions from the audience ahead of this event. So I will select some of the questions from the pre-collected questions. I'd like to ask the first question.
까지 수직 이착륙 항공기의 대표적 헬리콥터를 개발하여 성공적인 군에
So your company has successfully provided eVTOL and fighter jet and helicopters, and not just civil aircrafts and others. Mostly these aircrafts are now being used for public purposes, like for evacuation. So your research, is it for multi-role, like both civilian and military, or is there any priority here?
굉장히 답변이 주저되는 내용입니다. 왜냐하면
It's really hard to answer the question. So if you have read UAM report, everyone believes that UAM will take off after 2035.
천억 이상씩을 투자하면서
And it's really difficult to make a profit if we make like 100 billion won investment every year. When you look at the UAM business model, the aircraft business only takes about like 90%, and the remaining goes to construction and infrastructure. These companies have a long-term vision because they have a deep pocket, but for us, we are specialized in aircrafts.
향후 5년 동안
For the next 5 years, we have a plan to make investment in the future businesses, not just UAM, but also the missiles and others.
바로 우선시해서 들어가기는 굉장히
It's really hard to prioritize the civil application, but we have to think about what we are good at it, what we are good at.
수송이라든지.
For example, military transportation logistics.
사업적으로는 일단 이게 좀 개인적인 생각이지만
This is my personal opinion.
군에 관한 어프로치가 가장 먼저라고 생각돼요.
I think military approach will come first. Then we are going to think about a civil application. Certification, demonstration can be done in the civil private sector to really make a profit at the company. I think we have to think about the military application first. Thank you for your answer. Let's move on to the next one. So you have developed a lot of different aircrafts. You have much experience in it. For a successful UAM aircraft development, you have been thinking about a lot about it. What is the biggest challenge for you in terms of the eVTOL aircraft development? And what kind of support do you expect or do you want from the government?
이제 이 질문을 처음 들었는데 굉장히 좋은 질문.
So I think this is a great question, and no one really has ever asked me this. So aviation is a lot different from automobile. It has wings, so it may something may go wrong. It's very sensitive to the safety.
저희가 외국에서 인증되고 있는 소위 잘 나가고 있고 잘 진행되고 있는 기체들을 보면
And the aircrafts are certified in foreign countries. They might achieve a commercial success as well. But if they are introduced in Korea, there are some limitations in their application in Korea for us. Because
그 기체를 활용해서 어떤 개조나 저희가 원하는 사양대로 하려고 하면
if we want to have the specifications we have, well, there are some limitations because of the export permits of these aircrafts. That's our challenge. And in aviation, certified or not, will decide everything. Certification itself can cost a lot. So that means that you have to have the proprietary original technology, and the countries that can have competitiveness in the global community. So funding itself is not difficult, especially for startups. In the early days of UAM, the government should prime the pump for the industry to actually activate the market and help our companies enter the international market. Let's move on to the next question. So, safety level required for private application and military application, but your company is trying really hard to achieve a model that meets both safety levels. This is something that is really, I think this involves a professional expertise. In the US, there is FAA. In Europe, there is ESA. ESA and FAA certification standards are not applied for the military applications.
TACC라고 그래가지고 그 부분을
And TACC are used here. So these are our own tailored standards for the military application. So as long as we have an agreement with the customer, that's fine. So as you said, we are thinking about, we are designing an aircraft that meets both the civilian and the military aircraft requirements. And of course, we are going to have Korea-specific standards for certification here in Korea. And our aircraft's characteristics can be also reflected into this here.
뭐 유사하겠으나 군이 요구한
Well, there are some specific requirements for military missions, and they should be considered for our business. I think this is my last question. Boeing and Airbus is not really they have not been really active in the UAM market because they eat up the helicopter market. So what do you think about it at KAI or K? It's really hard to answer. Maybe you can think about it like this. So when you think about the payload, helicopters' payload is like 1,000 to 3,000 kilograms. But UAM, we talk about 600 kilograms. Jorbit, they talk about like 500 kilograms. And for the endurance, helicopters is like 3 to 4 hours, and it's only 1 or 2 hours for UAM aircrafts. So there are distinct differences. So what we are more worried about is the civil aircrafts.
AAM 개념으로 regional air mobility
Regional aviation mobility will be introduced to connect point to point, and national flight routes, interstate flights might be affected with the introduction of UAM. Thank you for your answer. So
Next, we have some questions to Mr. Hong Long Cho of Volocopter. This has been pre-recorded. So the first question is, the Volocopter has chosen Singapore as the first entry point for your business in Asia. What are the strengths of Singapore in terms of UAM services? Also, do you have plans to enter the Korean UAM market? If so, can you tell us about your plans?
Sure. I think we see three aspects for Singapore that put itself at the forefront of UAM. The first is the regulatory investment that the aviation regulator puts to stay at the forefront of the aviation industry. The second is the government alignment as well as the effectiveness of its government to allow for a new industry to launch. The last is the talent availability as an aviation and business hub that is frankly unparalleled in the Asia-Pacific region. So when we look at our cooperation with Singapore, we've now been working with the government for 5 years now. From the announcement of the cooperation in 2018 to the flight trial in October of 2019 to the commitment to launch in December of 2020 and now just yesterday with the publication of our roadmap to Singapore launch, it's been a very fruitful cooperation on both sides. On the regulatory investment side, we see Singapore trying to position itself as an attractive city for eVTOL companies. It is one of the first to update its working arrangement with EASA to allow for concurrent type certification validation, which accelerates our ability to bring the aircraft to the city-state once it is type certified by EASA. On government alignment, the fact that Singapore is a small island allows us to work effectively at all levels of the government through our partner, the Economic Development Board of Singapore. And they've shown that they're willing to take steps toward innovation, such as the adoption of electric vehicles, right? The EASA collaboration that I mentioned, and of course, the Green Plan 2030. We believe that this, combined with the excellent reputation that the CAS has in this region, mean that Singapore is the only gateway, right, for our market entry to the Southeast Asian market. Last but not least, as an international business and aviation hub, we can easily hire a very effective group of aviation and business leaders with the wealth of experience that we need, right, to launch this new service. Now, when it comes to Korea, we see Korea as a very important market, and it very much sits amongst the top of our launch market lists. We are honored to have been invited to participate in the flight trial event in Seoul and Incheon in November of 2021. And we really applaud MOLIT and the Korean government's efforts to promote the growth of the AAM industry in Korea. We view Korea as a very active and advanced economy, right, in developing the AAM ecosystem, with both public and private sector players investing very heavily in the initiative. And as I mentioned, we've hired now the first people on the ground in Korea, working with both national and local city governments through collaborations with our strategic partners, right, with the ultimate goal of course, launching commercial service and welcoming passengers on board our aircraft in line with the government's KUAM initiative.
네, 두 번째 질문 드리겠습니다.
So this is our second question.
볼로콥터는 화물용 드론.
Volocopter is developing a variety of aerial vehicles, including cargo drones and 2- and 4-seater aircrafts. Can you tell us about the markets you plan to focus on in the Asia-Pacific region and your strategies in this region?
So as we've shown in our presentation, besides Singapore, we're building up major partnerships in China, in Japan, and in Malaysia. So I think having a major partner is a key to our strategic rollout. Now, we plan to roll out not only air taxi services, but also deploy our cargo drones in these markets, which really helps to familiarize the local regulators, the government, as well as the people in those countries of our products. Right? So there is a positive synergy between the launch of the cargo drone, the Volodrone, as well as the air taxi, the Volocity. Now, with the Volodrone, we expect to revolutionize the cargo drone space by offering a new, fully electric, sustainable, and cost-effective way to transport goods across difficult terrains like mountains, and also to remote islands. With more than 400 inhabited islands, we see Korea also as a market that will have very strong demand for our Volodrone aircraft.
네, 다음 질문도 드리겠습니다.
So the next question is, although Volocopter is based in Europe, it also has plans for many projects in North America and Asia. What are the biggest challenges and biggest advantages for UAM business in Asia compared to Europe?
Sure. So maybe let me start with the strengths, and then I go into the challenges. I think the very obvious strengths that the market has is the huge potential for AAM to revolutionize travel in the megacities in the region. Right? When we specifically look at Asia-Pacific cities like Singapore, like Seoul, right? Like Shanghai, like Osaka, right? We see a huge potential, right, for air taxis to make a difference in the way people travel within the cities. Now, many of the governments in this region are forward-looking, and we applaud again, MOLIT and the Korean government as one of them that's really looking to bring AAM as the next forefront of aviation and the next forefront of economic growth for their country. The last but not least, I think the governments in this region also have a very pragmatic approach to AAM. There is a sense that, hey, if it's going to help relieve the traffic congestions on the ground, if it can be done in a safe, right, and sustainable and affordable way, there's no reason for us to not adopt the technology. So I think the pragmatism and also the willingness to accept technology is a huge strength for markets across this region. Of course, they come with some challenges, and for us, I think the most important one as a German company coming into this region, of course, is that we have multiple markets that have different languages and different cultures that require a significant amount of investment to understand on the way of doing business in order for us to effectively localize and commercialize our products and services. This extends, of course, to the aviation world, where we see our certification and licensing needs being necessary in every market where we go to. So, as an example, amongst the many other approvals that we need, we would need to validate our type certificate, right, for our aircrafts, as well as to obtain or to use a separate airline operating certificate in every single country that we enter. Now, in Europe, as an example, with EASA and the European Union single aviation market, we would not actually need to do a validation of the type certificate, and we only need a single airline operating certificate to operate across all of Europe. So the regulatory burden of operating in Asia Pacific in every single country is significantly higher than that of Europe.
네, 마지막 질문입니다.
So this is the last question. Last year, UAM demonstration projects were carried out at major airports in Korea, including the Gimpo and the Incheon International Airports. Volocopter participated in those demonstrations. What were your impressions about the demonstration projects held last year in Korea, and do you have any plans to participate in other projects?
From what we saw, the excitement that we felt was palpable. It was very much a technical and logistics challenge to fly at two major international airports within 1 week of each other, right? When we are flying in our technical and operations team from Germany in the middle of COVID, right? Thankfully, this was right before the Omicron wave hit, right? So we were able to pull this off very successfully. But we were also quite surprised at how the Korea's public and private sector collaborated together to really build such a new industry and to develop this ecosystem in advance of the flight trial. We very much appreciate the support from the Korean government and the event organizers to make the event a success. Now, we're in the midst of planning our next steps in Korea, but I think it's fair to say that we plan to be aligned with the national government, especially MOLIT's plans towards launching our commercial services in Korea. And in due time, I will be very happy to share those plans with you.
네, 감사합니다.
Thank you so much. Mr. Hang Lung Chu from Volocopter.
And I'd like to ask two questions to Edward Xu of EHang. The first question is, EHang is currently piloting UAM aerial sightseeing and many different public uses in China. Can you tell us about the progress so far and your plans for the future?
Yeah, thank you. Actually, we launched the test operation, I think as early as 2019. We first built our test ground in Hezhou, which is in Guangxi, west of about 300 kilometers west of Guangzhou, our headquarters. And so this proved to be quite successful because we earned the certified title by CAC as an unmanned aerial vehicle test base in China, with specific focus on aerial sightseeing. So in total, we input about 30 EHang 216 AAVs, and this is a locally famous tourism spot, and so was quite well received by the tourists. And later on, last year in Shenzhen, we entered a good collaboration with Uss Interoperability, which is a conventional helicopter company, to launch aerial sightseeing experiment in Shenzhen, in the east of Shenzhen, which is called the Malang Hill. And it has very beautiful scenery of the sea, and it's built in the middle of hill. So, which also gained a lot of attention and interest from various parties. And specifically in 2021, last year, we launched an initiative to have 100 AAV routes built within China. The focus in the Canton, Hong Kong, Macau, Greater Bay Area. Specifically, we had a local partnership from real estate operators, hotel owners, and some infrastructure operators as well. So different parties showed good interest and also made a generous investment in the infrastructure and also the land, so that we are able to expand our network in southern China. And so definitely we see very good enthusiasm and interest in this, autonomous air vehicle sightseeing, because it gives people a new way of sightseeing to experience the beautiful sceneries, which cannot be, appreciated from the ground. So, and also it provided good accessibility. Some of the areas, such as the top of a mountain, and also in the island area, which is very difficult to access from the vessels or from the ground. So this proved to be quite successful. So in the future, our ultimate goal is to implement urban air mobility, which is transportation of passengers and cargo. So air sightseeing is alternative way for us to gain operational data and to build our team and also build our experience and prepare us for the ultimate launch or commercial operation in the urban area. But this requires the certification, so that is why we are working very closely with CAC in terms of certification of airworthiness or type certification. And so we are hopeful that once we get this TC, we are able to apply for your license so that to launch more urban transportation in major cities in China. Thank you.
네, 감사합니다.
Thank you for the answer. Let me move on to the next question. So EHang is pioneering the UA market fairly quickly from China to Europe, Asia, and North America.
장점이 있을 것으로 예상됩니다.
So I believe the approach will be different because different countries have different systems and have different systems and environments. Can you briefly tell us the strengths of EHang that are different from other UAM manufacturers, and also the characteristics and strategies of each region?
Thank you. I think this is a very good question, and because I think our we put the advantage in that this is maybe first mover advantage, because as I mentioned in my presentation, and we in 2016 we first launched the world's first autonomous air vehicle in Las Vegas. This is the world's first fully autonomous air. And so basically, our focus is on the safety. The safety is of paramount importance. How to ensure safety? We believe that autonomous flight is a way to ensure safety, because big amount of data and evidence shows that human errors is a key cause of helicopter accidents in the past decades. So human beings make mistakes, but the machines don't, right? So we try to make our flights fully autonomous and computerized, and so that to make the flight more accurate and safe. And second, we focus on this point-to-point flight route operation. That means for every route has been predetermined and tested many times before we really launch our flight. So our AAVs follow exactly on the route. In this case, it eliminates the risk of collision or other obstacles in aerospace. And moreover, the AAV has this auto-detecting and with a radar on it, so that it can detect any obstacles. And finally, we have this power redundancy system that to provide extra power to ensure safety. So basically, our EHang 216 has 16 propellers. For example, if any 4 of them fail, the aircraft can still land smoothly around. So by this, we mean that this has a power redundancy. And moreover, our system is platform-based. What means this is a real-time network connected by 5G network, and so it provides this real-time connection so that the command control center can monitor the whole operation of the plant. And moreover, we have designed these cluster management skills so that this allows the operation of multiple AAVs simultaneously. So imagine that in the future, if we put this AV or urban air mobility services in the cities, it is important that we need to be able to handle the operation of multiple AAVs, and so this requires the cluster management and also full automation with point-to-point flight routes. Otherwise, the risk can be very, very high. And we are afraid that this can cause significant risk to the cities and also the aircraft. So that means that we are not only a hardware company, we are more about the software and algorithm is IT. And so this is a combination of IT technology and hardware. So for different countries, they have different regulations. For example, in US, FAA require this manned flight first, and followed by automation. And it is also the same in Europe. For example, EASA also require the manned pilot test before automation. So, but in China, when we work with CAC government officials, they are quite acceptable to this automation concept. So that means we are working in China first for the certification of full automation flight first, and then we hope to gradually expand the model to other countries. But I think for Korea, it is very nice to see the government has very open mind and attitude that we did tested our flights in 3 different Korean locations, fully automation, right? So which proved to be very successful. And so we hope that we are able to gradually, launch our, automated flight in the future in Korea, maybe. Thank you.
네, 온라인으로 접속해 주신 열정적으로 답변해 주신
Thank you for your passionate answers, Edward. Thank you so much. Let's move on.
Next, I'd like to ask the next couple of questions to Mr. Jung Min-chul from the KAC. So in Korea, according to the KUAM roadmap, the Korea expect to commercialize the UAM by 2025. So at the initial stage, what kind of vertiports do you expect to see? And in many of Korean cities, it is densely populated with a lot of buildings across the cities. So even though we have vertiports related technologies and we secure safety, without social agreement, it will be very difficult to build a vertiport. So do you have any ideas to increase the social acceptance? Well, we had this grand challenge, and there will be, according to the KUAM roadmap, our commercialization goal will be 2025. Commercialization means that passengers will need to pay fee to hop on this vehicle, but this will be very initial stage, so there will be only a few curious passengers who would try this UAM. But we believe that around 2023 or so, we believe that we can build a kind of like a certain level of vertiport and related infrastructure. So in Korea, we have eVTOL vehicles with the noise level less than 45 decibel, but it will be very difficult to build the vertiports in the neighborhoods. So how can we do that? So initially, we can build this vertiport in open spaces such as public parking spaces or near the park. That would be the best way to go. And as people gradually see the benefits of using vertiports, then we might be able to expand these facilities near the residential places. Well, many people in Korea, most of them think that this kind of vertiports will create a lot of noises. But having roads where a lot of vehicles run along, people are relatively less sensitive to the noise. So initially it might be a little bit difficult to achieve the social acceptance, but it is important that we gradually show the advantages of having this kind of advantages. Thank you. So my second question is that latest news article says that there's a project that is going on around near the Gimpo airport to build vertiport. So other than Gimpo airport, can you tell us the initial types of UAM services and what would be the most optimal sites for those kind of vertiports at this initial stage? So you have asked me two questions. You have asked me the best site for the vertiports at the initial stage. So we need to secure this kind of vertiports, but we would face some challenges and constraints. So let's talk about using existing transportation such as KTX. We can quickly reach from Seoul to Busan. But in Gangnam region, from Gangnam region to Dongtan, these are highly congested and highly populated regions, and I believe these kind of regions will be the ideal places to build vertiport in the initial stage because it will create a lot of demands. So it is only natural to build such kind of infrastructure to the places with high demands. And we, as I mentioned, acquiring social acceptance is really important. Thank you so much. I'll move on to the third question. Well, the construction and operation of vertiports are different things, and you have mentioned a lot about this during your presentation. So can you tell us about your plans for the operation of the vertiports that has been established? Well, I somewhat agree. Well, some of the vertiports that have been established can be operated by private sector. So there will be first comers in the market. So in the initial stage, the government can support to facilitate and promote this industry to help first movers to take off their business. And afterwards, when this sector is a little bit stabilized, then there will be more people coming from the private sector in this business. So in the initial stage, we can make a tryout. We can maybe build this kind of vertiports in a couple of places across the country, and then see how it goes as we move forward. Thank you so much for your insightful comments.
So, lastly, I'd like to ask you some questions. Lee Seok-gun from SK Telecom. SK Telecom is a very famous telco in Korea. So I'd like to understand why did the company choose mobility market like UAM as its future business? Can you tell us what is also the most difficult thing when entering the UAM industry? SK Telecom has provided mobility services like TMAP for the past 20 years. We have necessary data as for traffic, and I think we've been studying how to better utilize such data. So we also launched related service like first mile service like taxi. That's how we first thought about UAM and air mobility. So as UAM can break ground in terms of overcoming the existing limitation of transportation, Because with the existing transportation system, we cannot go from Gangbuk to Gangnam in 10 minutes. But this limitation can be broken by UAM that also attracted the attention of the leadership of our company. So the most difficult challenge when entering the industry, well, there are a couple. The industry was triggered by Uber Elevate that company led the industry in the earlier days, but after its divestiture, now we have been seeing a bit different ambience in the industry. But after its acquisition,
연장선에 있는 그런 서비스가 될 것 같기도 하고.
I think it will provide a service that is a continuation of the conventional aviation services.
좀 더 영역을
Maybe the conventional aviation companies may pick up different roles, and this can pose a threat or barrier to other players. So we are still waiting for the commercialization. So I think we have to move forward based on the social consensus. Thank you for your answer. Let's move on. The second question is about your partnership with Joby. What made the company choose Joby among many eVTOL manufacturers? So what is the future work scope and plans? SK Telecom provides different services. We always trying to partner with the number one player of a given industry. And so in the eVTOL industry, I think Joby is an undisputed leader.
팀의 모빌리티라는 회사를
We established T-Mobility when we spun off T-Map. So we were very much interested in the technology and know-how of Joby. Since we already have a relationship with Joby, and Joby acquired is former Ubi Elevate, it already has achieved the vertical integration, and it also provides wonderful services. That's why we entered a partnership with Joby. Now we're discussing the business in Korea, but about how we still have a long way to go to turn it into a full-fledged business. It's not one of many partners, but it will be a very close, tight collaboration. Since we have limitations as a foreign player, I think Joby needs to work with the regulatory bodies also, and as well as with the consortium too. The government research projects, Grand Challenge, these are very important, and we also deliver the message to Joby, and Joby understands it. Thank you. I think this will be our last question for the panel discussion. Many telcos are actively getting involved in the UAM services. Are you aware of any UAM services provided by overseas telco, and how they are different from the ones provided here in Korea? I hope other telcos in foreign countries to have interest in it. I don't really have seen any cases like that. UAS and UTM are the areas where other telcos are getting involved in, but UAM is a bit difficult because the feasibility study itself is a bit difficult to have now. It has a barrier, and I think you must have already watched the video on YouTube. It was strictly from the perspective of telco, not from the perspective of UAM. We are trying to act in the earlier days because first, government is creating an environment for it.
유틸리티 기업으로 인지되는 부분이 조금 있습니다.
And in Korea, we are constantly being asked to come up with new businesses and services, unlike in foreign countries where telcos are just considered as an infrastructure company. So we've been talking about we've been asking different questions about UAM, and we also received answers from our speakers today. We actually need to ask you the questions from the YouTube and from the audience. Maybe we might need to collect these questions and deliver them to the speakers due to the time constraint. Thank you very much for your participation and also your time. Thank you very much.
So a big round of applause to our wonderful panelists and our moderator. Thank you so much. Cheer for all the dedications and commitments for all people involved in this industry. Thank you so much once again for all participants.